Good morning, everyone. We will start the last day of our annual conference. Today, we will start with high-performance computing, modeling simulation GIS for environmental monitoring and social intelligence. After this panel, we will have a coffee break. Then we have also a lunch break, hosted. And we'll finish with one more topic after the lunch, and about 1400 we will go to finish our conference. Just to remind you to use our online platform plus questions for lecture. You have passwords in your agenda. So I will now give the floor to our moderators to start this panel. Thank you.
Thank you very much, Matt, and good morning to all participants. Today we continue with the session which we started yesterday, actually. It's again about high-performance computing, modeling and simulation, and so modern today usage of artificial intelligence. Personally, I don't like it so much, but it's very practical to use it, very convenient. For me, the classical modeling is still the better way to understand something, to model something. But as I said, however, if you'd like to have something very fast as a result in domain of modeling, you have to use artificial intelligence. Now I'd like to give the floor to Nina to present our participants.
Good morning from my side too. Our first presenter today is Professor Piotr Giro. He is a professor in the Institute of Information Communication Technology from the Academy of Sciences. His main interests are in statistics and high-performance computing. And his topic today, what he's going to present to us, is an HPGA service for estimating the brown bear otters actors for population in Bulgaria.
Thank you for presenting me. So, thank you for organizing, for very nice conference that you organized, a very good facility here. So, see the presentation. Okay. Here is my presentation entitled High Performance Data Analysis Service for Estimating the Brown Bird Population in Bulgaria. This work is a joint work with a big team from different institutions. Some people are from my institute, Institute of Information and Communication Technology, mathematician and programmist as well. And the other is expert from the Executive Environmental Agency in Bulgaria and also biologic from the National Historical Museum. So, regarding the motivation here, first, I have to emphasize that in my presentation, I also will mention the climate change, as in a lot of presentations that was mentioned, this climate change that affects the human life. But here, the climate change affects the animals. So, motivation to create this software tools is habitat directive that requires strict protection of this species. We know that the brown bird is a priority species for the conservation of mammals in the European Union, as well in Bulgaria. This species is involved in the Red Data Book of the Republic of Bulgaria. And in order to create this service, we integrate different data from different sources. First, we summarize the data from the national field monitoring in the main mountain habitats. You see on the presentation, I list this main data with the blue, in the blue light, blue color. Also, as well, we summarize use the GPU's coordinates of the bird traces sign. Other sources that we integrated this software. This is the European Terrestrial Reference System 89, ETRS 89. You see on the picture on the presentation, and these trial areas are square 10 by 10 kilometers and cover the main habitats. And you see the map of Bulgaria and the mountain. You see how this area cover the mountains. So continue in the next slide. Here, the number of grids of each subpopulation area. The main population area is Vituša, Verila, Plana Mountain, Riva, Pirin, Rhodops, Western Rhodops mainly, and Central Balkans and Cotton Mountain. You see the number of these squares, these unique numbers for each square, and how many squares we use to make this national field monitorings. The national field monitorings we organize every year in the end of October and beginning of November for 2 days. So the other source that we use, this is we take from the current one color system, and here in different kind of forest cover our mountain. We use this because these places are habitats of the birds that use for foods, regarding the foods for their life. How we integrate the both 10 by 10 kilometer square and different forests. You see here for the in Rhodops mountains, as well in the Vituša mountain, how this square cover this main habitat of the brown bear population. So in order to collect to the bill sign, we use transect methods. Transect methods during the national field monitoring. For H square here, we have approximately two transects with length 8 and 10 kilometers. During the monitoring, people from forest administrative units to walk in these areas and summarize the brown bear sign. So we collect this sign with the HPC poster in the Executive Environment Agency, and use data as input file for our service. Here you see the window that appear when we start executive file of our products. And here is the scheme how evaluate population. We have actually in this scheme two screen. First screen, screen one, we regard it as reproduction process. And the screen 2 is actually computational process, and we estimate the brown bird population there. So in the first step, we collect observation of the national monitoring, read input files, and after that, expert from the executive environmental agency create unique trace, unique file with unique trace of the bird. How this is done? Here, how look the input file that we that collect the data from the national future monitoring. Look at this. We have in GPS coordinate in the last two columns and the different kind of sites. And second input file regarding this 10 by 10 kilometers grid. This is trial areas. So this is the screen. This is the screen. First screen. Then we read input files, and this screen is used in order to help expert to create this file with unique traces, because we receive approximately 300 traces from the national field monitoring, and when we select these traces, we receive one new file with unique traces, approximately 80-90 sites. This window help the experts to create this unique file. Some rows are marked with one in the same color. Here you see how we mark this line that is blue. This is actually potential trace on one in the one bird. But explain how to decide if these traces are different or belong to one individual. Additional window would help expert to select unit trace. This is the you can compute distance between two traces in the above small window that we have a red and blue line, and also using the Gmap in order to see the GPS coordinate of the trace, and after that expert decide if which traces are unique. So this process continue, and when the decision is okay from the expert, they mark unit traces in the column with skip. Here we mark unit traces in the skip, recover again with some button below to rest trace, and after that we find this unique file. The second screen, we actually compute the population of the brown bird. This is fine of the two sets using the maximum likelihood method for the input effects. And the second step is we input the grids, which contains transects not visited during the national monitoring. What happened here? In the second window, we compute population in the table left below, and above table in the left. In the green, the unique traces are distributed in different trial areas. And the other table, this is additional window, you see the reference values of the main population area. Here, I will skip this slide. Here is the mathematical formulas for statistical estimation of the using maximum likelihood estimation. And some new features are structures by unique traces. Age, you can estimate, you can distribute population by age. For this, we introduce this age structure table, and that is this table show the size of footprints and how individual or age. Using this table, we find distribution of the population by age. The next additional next slide, please. And next, here is the list of pressure and threats. You see some threats. Last threats is the climate change, other is poaching, and the others. These threats are also incorporated in the software. And if we summarize some threats during the national field monitoring, we also these threats affect to the population. So, see we can calculate the population using some threats. Added in this table the number of threats that we summarize during the monitoring, and finally I will show some results that we received in the fourth national monitoring provided during 2017 to 2020 years. This is actually the total population is the last line, starting from 401, and in 2020 457 individual we estimate. But actually, we compute also in the interval in which this mean value are fixed in these intervals. Also, in distributed the number of population in different mountains here. You see, this is the results. And the first table, this is the number of unique traces. So I will stop here. If you have a question, I will answer later. As a conclusion, this service was created for the needs of the Environmental Executive Agency, which is under the Ministry of Environmental and Water, with the financial support of enterprise for management of environmental protection activities. This is Polish. Thank you.
Thank you very much. That was good. We have time for a very short question, if there is some from the audience here. Yes?
There is no statement, actually. being a representative from the Ministry of Agriculture and Food, I'd like to give a broader perspective, understanding the potential consequences of my statement. So, thank you for the floor. Very interesting presentation, very well developed method, but there are a few minuses. And I will give you a overlook of the problem, not only here but on the Balkans, where is concentrated the predominant part of the population of brown bear here. In Romania, because they still are based on such methods for monitoring, for the last 15 years they have 29 casualties, human casualties from bear. Meanwhile, in Croatia and Slovenia, they did something what we are going to do this and next year with the support of the Ministry of Environment and Waters. They did a DNA analysis because estimating different number of animals only by the weight and the length of the stem is something that does not give a very good perspective of what is the actual size of the population. And the colleagues from the environmental executive agencies says that this method is very well developed and used every year, but it gives trends, it does not give the exact number of the brown bears in Bulgaria. And we, the foresters, by the way, I wrote a couple of things. The foresters does not do the monitoring. The people from the environmental ministry and the local branches of the ministry, also the environmental agency are doing the monitoring. And the threat of reduction of all forest is not only because we're increasing not only the cover of the forest, but also the age of the forest. So these are not true according to our understanding and information. Bottom line, because I don't want to take too much attention, in the next 1.5 years, we will know exactly how many bears based on DNA analysis we have in Bulgaria. And then we eventually will revise the action plan that was adopted last December by the Minister of Agriculture. And on the basis of the adopted measures, then the colleagues can eventually update the software on the basis of the true information of the DNA analysis, they can continue their monitoring.
Thank you very much. Okay, we will continue because we are a little bit behind the schedule. So our next presenter is going to be Elena Bogoeva. She's a PhD student at the Institute of Information Communication Technologies in Bulgarian Academy of Sciences, Department of Communication and Computer Systems. Her main interests are programming, electronics, automation, computer and communication systems, and robotics. So the topic she's going to present today to us is application of ICT in interactive learning environments in emergency situations.
Good morning, everyone. Today I'm going to present you application of ICT in interactive learning environments in emergency situations. Introduction. In the contemporary digital age, the use of information and communication technologies is the educational process is inevitable. ICT is transforming the way students acquire knowledge and skills by providing tools for more accessible, effective, and adaptive learning. This study aims to explore the application of ICT in interactive learning environments and to analyze their possibilities for improving the educational process. The research brings out the basic principles, advantages, challenges, and perspectives that accompany the use of ICT in ILEs. So here you can see the concept of interactive learning environments. You can see in table 1 the advantages and disadvantages of interactive educational environments. I think that the advantages are more, and this paper doesn't this paper doesn't show only the interactive learning, but the old methods too. Here you can see the application of interactive learning environments in contemporary education. You can see them on figure 1, the key elements in interactive learning, which are interactivity, flexibility and affordability, feedback, personalization and training, multimedia resources, and social interaction. Application of information and communication technologies and interactive learning, training for reaction and action in crisis situations, disasters and accidents. So here are the instruments which here are the instruments containing in ICT for interactive learning environments, e-learning and online courses, interactive simulations and games, video conferencing platforms and webinars, mobile applications, digital educational resources. And here is an example model of a lesson for survival during an earthquake. You can see the introduction, the presentation of the topic of the lesson and its goals, explanation of the importance of the preparing for an earthquake, especially when we are in indoor space, training on the right actions during earthquake, training on the correct procedures and actions to be taken during an earthquake in indoor space, interactive earthquake simulation. Here we spent most of the time, like around 30 minutes, use of the interactive simulation in a virtual environment that simulates the earthquake in an indoor space. Students will be forced with different earthquake scenarios and will need to take the right actions for survival. Scenarios may include different sites such as buildings, schools, homes, etc. After this, there is an analysis and debriefing, which is a discussion of the simulation results and evaluation of students' response and actions, giving feedback and advice on improving survival skills, and conclusion. So here you can see the optimization we are offering. So on figure 3a, there is a simulation without neural network, which the simulation is based on predefined actions, and you can see that we always go to the final goal and end, no matter what are the actions of the students. On figure 3b, you can see simulation with neural network, which is optimized by different weights on the actions of the people. So, yes, this is the simulation. The continuous development of technology and the opportunities they provide cannot completely replace traditional training, but their use and improves and changes it continuously. The example model of an earthquake survival lesson presents a realistic training scenario in which training, interactive simulations, and analysis of participants' actions are combined. The proposed optimization of the simulation environment by using neural networks represents an advanced approach to improve the realism and effectiveness of crisis response training. Thank you for the attention.
Thank you to the speaker. Are there any questions? Yes, go ahead. Microphone, please.
Thank you very much for your nice presentation. and to listen that people are doing such investigations. It's very important. So my question is about this lesson you presented as an example. First of all, how long you consider you need to have this lesson? And second, do you consider that this lesson is enough for education? Because after the lesson, people usually forget what they studied.
Thank you very much. Finished on that report. Thank you for the question. Like in this scenario, we are the simulation is around for people who are from 14 to 18 years old. And I don't think it is very effective to do it once a year. I think that it should be done many times. And for the optimization model, this model is used not for students. The student model is where the actions are predefined earlier. But with the neural network, it's not possible to do this on children because they can be feared very easily. And the optimization model is like for people who are much more older and with the to be connected with their work.
Okay, another question?
I have a question about this neural network. When the student perform an activity, does this simulation is changing in accordance to the activity performed?
Yes, exactly that.
Because
Yes.
this is very important.
Yeah. Yes.
You to just highlight it because I think that this is the gist of this point.
Yes.
Thank you to the audience. If there are no more questions,
I have
you have to go ahead.
one very short, and it's also related to the previous presentation about validation, estimation of the accuracy achieved. Recently, I heard about interesting method to assess the training quality, usage of virtual student based on artificial intelligence. So among the training audience, we have such virtual student. At the end, we can understand, asking this AI, what was the quality of the process. Do you have such method to assess the training process and delivered information?
Thank you for the question. I unfortunately don't have such a method because these trainings are used with teachers, and teachers should show this result. It's not AI based. I mean, thank you.
Okay, so we will continue with our next speaker, who is Kalin Kapanov. He's a PhD student at the Modeling and Optimization Department of the Institute of Information Communication Technologies in Bulgarian Academy of Sciences. He has over 15 years of experience in national security. He is specialized in open source intelligence and analysis of propaganda and disinformation. His academic research focus is on developing innovative solutions based on artificial intelligence. And today, the topic he's going to present to us is leveraging social media data and artificial intelligence for improving earthquake response efforts. Kalin, the floor is yours.
Thank you very much, Nina. As my colleague said before, I'm continuing with the earthquake scenario. I'm here on behalf of my colleague Elizar Urbanov and Professor Tatjana Atanasova. So we did some research how to use social media to complement the data, which is crucial during the earthquakes. As the Colonel said in the beginning, I'm also very pessimistic about using AI. So for that reason, we do our tests by ourselves and we show pros and cons about different use cases. What I would like to say is, okay, we have the traditional emergency services, we have the methodologies which work best, but then we can use the decentralized services as social media to bring additional data. So those platforms, when the data is aggregated, as later I will show, it could bring valuable information to the emergency response teams. So what I try to point out in the beginning, it's this data, it's additional to the traditional services. It won't become just using that data, but complements the efforts. Here, the main goals we try to point out is what could be the role of social media during the earthquake responses, and how the AI could help in processing the data. And in the end, when you have all this automation put in place, how to improve the social awareness and the decision-making process. What we try to do is trying to find out different challenges and opportunities. Of course, if the earthquake is devastating, the communication infrastructure won't work, but if it's not, social media could help in that process. We have different management capabilities, and here are also different platforms. You have to aggregate it, the data, so different approaches. And for me, what is maybe the most interesting is the geotagging, because in the past, we have a lot of applications which help people to by themselves the geotagging, but nowadays this is maybe under 1%. So this is where the artificial intelligence comes in place to help us with the geotagging. Of course, the APIs in the past, most of them they were free. Now they're moving to the paid version, and here with Twitter, former Twitter now X. It's a good example when a lot of the research were free and easy to do in the past, and now if you want to use the API, it's paid. And again, so far, at least I don't know in Bulgaria, is there integration in the emergency management system with the social media data. So this is another challenge that should point out. And we choose one in our experimental part is the earthquake in Oklahoma. It was 5.1 in beginning of February. So it's one of the major one during the last, I believe, 1 or 2 decades. So it covered most of the state, and it starts around midnight. So we use the Twitter data. We choose the period from the beginning of the earthquake and the next 7 days. And what we did is 2 types of queries. Use the keyword one with Oklahoma and earthquake. And here to point out, of course, if we choose another keywords, different cities, will bring different results. That's why we complement that with the location-based query, which was with 250 kilometers radius, which covers most of the state, because as you saw in the previous slides back, I think it covers the data. So what we can, in the end, we have 8,900 results. So almost 3,000 are the posts and almost 6,000 are the comments. So the posts, we assess that we cover most of them, which happened. But for the comments, we are just up to first 200 for each post. So it's not the full data set, but it's enough to get the main idea. And the total statistic is, as you can see, more than 300,000 posts and 2 million likes and 223 million views. And what was interesting, as expected, people has the highest activity in the first 24 hours. And because of that, it was hard to represent just the whole period. That's why we use the temporal spread to use activity. Here you can see that, as I mentioned before, the past activities when the earthquake started. It's just a few seconds after that people start interacting with the social media, and I think this is one of the trends are happening. People tend to start sharing their activity in the social media instead of the government or non-government platforms. So that this is we use that, let's say, problem in user behavior in our benefit to get the data. So for the analysis, we decided to use the XML Roberta. It's a fine-tuned model of BERT model. It's an NLP. In our previous tests, this model brings very good results, and that's why we decided to use it. So what we saw is we analyze all the data, and it brings 82% of the posts with location-based entities. So, and 67% of that was related to Oklahoma State. And in the end, when we filter the results, we get 144 unique locations with the state. Those locations was manually reviewed after that to be sure that they fall under the state. And here I think it's a good time to point out that with Oklahoma and Oklahoma City, it's hard for the models to understand, to refer to the city or for the model. But in the end, we are looking at the unique location. So that's why it's for this point is not important to know is it the city or is it the state, because of course it's felt in the city also, the capital city. And we run that results also with the OpenAI GPT-4, and we get 95% accuracy. Here it's good to say that the data has some pre-processing before that, so 95% accuracy. It's based after the XML Roberta extract the locations. So we expect that higher accuracy rate. And in the end, of course, after all this data, we create interactive map. It has the, in this case, OpenStreetMap layer base, and it brought all the data from the XML Roberta. And we, in other tests, we also put the data with the GPT-4, which was the reason why we compare the results and we get 95%. And here we saw that the data compared with other platforms is accurate about where people report. But I think here is the most important part which we need to take in account to complement the emergency management system, and this is the keyword-based analysis. So words like healthy, shook, damage, and especially the crucial terms like explosion, crash, and fire, those would bring emergency attention to us, and people from the government organization would start manually reviewing those posts, because at first step we have the location analysis put in place, and then we extract the keywords. So it should cover, in most cases, the post which is related to the earthquake, and the experts would pay attention to that. Okay, so in our conclusion, we can say that the NLPs and AI, they filter and analyze the crucial data in a very precise way. And all of this, of course, it can be used in the situational awareness, in the response efficiency. And what is valuable is that the most of the data came in the first 24 hours. So it's crucial from the starting of the earthquake to get the relevant data and act as soon as possible, which will help for sure the decision making, in our opinion. Okay, thanks for the attention.
Okay, if there are any questions, please.
Thank you, Jamie. Thanks, sir, for your valuable presentation. It's important really to use the recent achievements of technology for such investigations. It will be very nice if you make your test when you have not moderated, like very only vibrations, how to say, but in stronger case, when you have a lot of damages, for example, like in Turkey last year. So go on with your investigations and I hope you get the results. Thank you.
Thank you very much, sir. Just to point out that we're also considering maybe testing on the data on the Turkey earthquake. There's two major drawbacks. The big data, it's a lot of data to analyze, and it's already outdated, so the platforms, they tend to hide the data from the older posts. So when we do the experiment, the earthquake just happens, so that's why I say we're sure that we get almost all the posts. And when starting collecting the data from the comments, they start to be limited in the views. So especially if you want to analyze the Turkey earthquake from the Twitter, for example, we get a lot of limitations about the data. And the other thing we have common between colleagues is we know that NLPs and LLMs, they behave well in English, let's say even in Russian, but when you start multi languages, they start to get bad results. So we don't have our own tests, how they will behave in Turkish. Thank you.
Are there any more questions? If not, we will continue with our next presenter. His name is Professor Lachezar Fiochev. He's head of the Remote Sensing and GIS Department at the Space Research and Technology Institute in Bulgarian Academy of Sciences. He holds his master's degree in Physical Geography and Landscape Ecology from the Sofia University and his PhD in Remote Sensing and Earth and Planets from Bulgarian Academy of Sciences. His main research interests are in optical remote sensing and GIS applications and landscape ecology and vegetation studies. He is a member of special interest groups of ERSL, International Geographical Union on Land Use and Land Cover Change, of editorial boards of journals, European Journal of Remote Sensing, Aerospace Research in Bulgaria, and Remote Sensing and of Land. He is a Copernicus Academy contact person of BAS and an alternative of Bulgarian representatives of Copernicus User Forum. Furthermore, he is also one of the Bulgarian representatives at GEO High Level Working Group in the European Commission. So his presentation today is called Monitoring Organic Icon Yields with Sentinel-2 Data. Professor Fiochev, the floor is yours.
So today I'm going to present our presentation, which is, you can see the authors. Fortunately, only I can attend the event because two of our co-authors are from the SADOVU and from the Institute of Karnopat, the Agricultural Academy, and the main author is in Bulgaria, but anyway. So, yeah. So the advantages of organic agriculture, I intentionally put the presentation in Bulgarian because I thought that we will get a mixed attendance from Bulgarians and foreigners. It will be much easier to grasp the concept. So the advantages are that the organic agriculture has ecological advantages.
towards the ecological toxicity and the use of biological resources. As you well know, the agriculture is a priority in the European Union. It also is good for sustaining and improving the biological diversity. It has specific advantages towards better food, better quality of food, and forages, and as well as it helps maintain our health and well-being. The main goal of the research, of course, is to study the use of Sentinel-2 data. As you may know, Sentinel is a family or a constellation of satellites on which the program Copernicus of the European Commission is built upon. This is the satellite component. The Sentinel-2 is an optical satellite. And how we can use this data to monitor the yields of fields sown with acorn. Acorn, as you know, is the predecessor of modern winter wheat or wheat, which we use for bread. But as some of you probably know or may not, the acorn has good food quality in terms of that it has less. I just forgot the name of this. I mean, it's towards, let's say, your full diet if you cannot eat
Gluten.
gluten. Yeah, sorry, the word is just slipped from my mind. So yeah, it has less gluten in the grain, so it's very good for specific dietary needs. So the materials and methods are basically grouped in three main groups. We used agronomical methods for which we relied on the institutes of agricultural academy, especially in Sadulu and Karnabat. So they performed the phenological observations. They track down the dynamics of the biomass accumulation through the phenol phases, so through the development of the acorn, as well as some biometrical measurements towards, let's say, height of the vegetation, the weight of the biomass, the weight of grain, etc. We used GS and remote sensing methods, our team, and of course statistical analysis, which is needed to interpret the results. Here the methods are in detail broken down. They of course can be read in detail as well in the report which is submitted. So it's better not to go in such deep detail. Moreover, I don't know what you can see from this slide. But overall, we have, as you can see, measurements of biomass, the length of the vegetation, which in this case is actually the height. But we collect samples from the fields because they are not in situ measured, so the statistic methods as well used. And this is how it looks through different phenological stages of development of the crop. So it's like a grass, like corn grass. I mean, we don't know how winter wheat looks like. It's not very much different. The only difference is that within the biological or organic, as it's known in English, agriculture, we don't have to use like a certain amount of pesticides. So overall, we have within the field a lot of weed. So the weed control is limited in order to get organic yield at the end. So these are different campaigns, as I said. It's towering and ripening, the last one. Well, For the GIS, we used ArcGIS Pro, which we had a license at the time. And of course, for the statistical analysis, GMP, SPSS, and PSA. As I mentioned, we extracted the data on the fields using sample sites or test sites. After each four columns of this, we have this 50 by 50 centimeters squares, which you saw already. And this have been placed in a platform of EOS. It's an American company which provides us full access to the archive of Sentinel. In this flow chart, well, you can see is depicted all the steps on module 2. We have to save time. And finally, in this slide, we try to sum up all of the results. We tested broadband vegetation in this from Sentinel-2 as much as we can, of course, derive depending on the input bands of Sentinel. And some indices, as you can see, perform, they are in negative correlation dependency, some are in the positive. Overall, it was found that 13 from the 16 vegetation indices which we tested are with a positive relationship with the yield. One of the main, let's say, parameters for food security, because here we should also put this into the perspective of food security, of course, is the yield. So we tested this against the yield. So 13 of the 16 generated vegetation indices are okay with the yield overall. And in the particular film phases, so in the phases of development, different indices are more sensitive than others. Let's say 5 of the tested ones, such as OSAMI, GDVI, AV2, and DVI, they are broken down in the paper. You can see the expanded course explanation feature keys and the formulas are correlating really well. 3 of them are not in a good dependency with the yield. But overall, we can use those 5 to assess the yield more or less. And we also found that in the so-called BDCH 75, it's a German film phase scale. 75 means the 75th day of sowing of the yield of the crop. Perform the best in terms of predicting the yield. Finally, we need to express our acknowledgements and, of course, thanks to Vulcan Biocert, which is the company which certifies and maintains this biological, this organic yield at the village of Białoreka, Argumai, and as well EOS Data Analytics for the granted access to the platform. Thank you.
Thank you. Thank you, Professor Fiucci, for your very interesting presentation. Are there any questions from the audience or from the online?
Yeah, there's a question from our online audience. Can we apply machine learning algorithms to Sentinel-2 data to predict any corn yields, and if yes, how?
Yeah, definitely. These statistical methods which we used are like the simplest from the statistical which we know, like a simple correlation, one-to-one relationships. Of course, we can feed in machine learning models with more parameters, and we can try to find which one performs best. But we just try to see which one of these, using like the simple statistical method of correlation, performs best in terms of especially vegetation business. Another way around is if we use all the data, let's say we put all the Sentinel-2 bands into the machine learning model and try to see which set of bands can describe best the yield. So this is another question which we can say. We can say try to execute. And of course we'll see a different results even probably better than this one because we we have something like 0.7, 0. Up to 0.8 R squared, but this is not quite well in terms of more accurate results. The issue with organic fields, I just mentioned that we have weed, which is mixed with the vegetation of the acorn, is that we should know exactly where the wheat is to discriminate the wheat from the main culture. So this is one, let's say, challenge which still needs to be addressed when we assess the
Thank you. Any more questions? Online?
No.
Nope. Okay, so thank you to our presenting once again. And we are going to our last presenter. Her name is Maria Topalska. She is a PhD student at the University of Architecture, Civil Engineering and Geodesy. Her main interests are in geology, hydrogeology, seismic response of foundation soil, and retaining structures. The topic of her talk today is the design accelerograms derivation for dynamic analysis of retaining walls. So Maria, the floor is yours.
Thank you very much. In my presentation, I will continue the theme for earthquakes, but from a different perspective, because I'm a structural engineer and I'm interested in the way structures respond to the the structures response to the seismic impacts. So this study that I will present is accomplished together with Professor Mikhail Kutova as part of my dissertation thesis. We will talk about how to select ground motions for the analysis of foundation soil, because foundation soil and superstructures react differently when we talk about earthquakes. In our current seismic code, Eurocode 8, there are no prescriptions for the selection of ground motions for the analysis of foundation soil. And the big issue is that foundation soil reacts inelastic, and this have to be we have to pay attention for this fact. So the first thing that we have to pay attention for is to set an earthquake scenario when we want to examine specific construction site. I will present 4 criteria for the selection of ground motion. The first one is related with the earthquake scenario. There are 3 main categories that we want to apply to satisfy there. The first one is the seismic event. Here, the seismic event can be presented by its magnitude, by its focal depth, and by its epicentral distance. Representative parameters of values of these parameters are available in the seismic hazard assessment. Secondly, we have to pay attention for site parameters. When we talk about foundation soil, the most important thing is the nature period of soil. There are several methods that we can apply when we want to estimate the natural period of soil. For example, we can use some established formulas, or the best way is to conduct some site measurements. And when we don't have information about the previous two, we can use dominant frequency maps if they are available. On third place, we have to pay attention for some targets from ground motion parameters. For example, this is the big ground acceleration, the duration. The duration is very important parameter because when soils are subjected to cyclic dynamic impact, which the earthquakes are, they tend to lose their stiffness. And when the duration is increased, so does the number of the cycles. So we can say that if earthquake is longer, the foundation soil will lose a bigger part of its stiffness. Another thing that we will talk about in the next chapters is the frequency. It is exclusively important when we talk about foundation soil. We will understand what's the difference between the predominant period and the mean period. So according to this criterion number 1, we can form a list of earthquake records which have potential for the analysis of a specific construction site. And we will continue with criterion number 2. Here we will talk about the frequency content. Many researchers back in time had used the predominant period as starting point when they examined foundation soil. But it happens that the predominant period is not the suitable, it's not the most appropriate parameter because it pays attention only for the maximum response of the system. And it is, I will go a little back. Yes, the predominant period is obtained from the response spectrum, which presents the response of a single degree of freedom system. And the foundation soil can't be represented by a single degree of freedom system. This is why we prefer to use the mean period. The mean period is obtained from the Fourier amplitude spectrum. This spectrum is characteristic of the earthquake itself. It's not characteristic of any system or structure. And in addition, it is better parameter because it averages in interval of frequency, which is 0.5 and 20 hertz, where a big amount of the earthquakes are actually happens exactly in this frequency range. So criterion number 2 is related to the equality between the mean period and the nature of period of soil, because when the exact equality is established, we can say that a resonance effect occurs, and there we can expect a maximum response from the examined system, the foundation soil and the retaining structure. According with criterion number 3, we can control the acceleration and specifically the spectral acceleration. The goal is to obtain spectral coordinates of the response spectrum of the earthquake higher than 90% of the spectral coordinates of a target response spectrum. So here, the target response spectrum can be easily obtained from the prescriptions given in Eurocode 8. They are very well presented because, as I said, it is Eurocode 8 regulates very well the earthquake impact over the superstructures. I mean, residential and industrial buildings. So the compatibility between the two spectra have to be accomplished in the period range which is proposed again in the Eurocode 8, and I have to remind you that actually the TS is the natural period of soil. the TS is actually the natural period of the structure, but in our case, it is for the soil because it's what we examine. So when these two spectra are not compatible, and there's a big difference between them, we can apply simple scaling. The simple scaling is very useful here because it changes the ordinance of the response and the Fourier spectrum, but it doesn't change the frequency content of the impact, which is very important because we want to keep, if you remember, we want to keep criterion number 2 accomplished. So it is not a classical matching procedure because in the classical matching procedure there is scaling and change in the frequency as well. Actually the equality between the ordinance had to be accomplished for the natural period of soil again, and some authors have proposed that if we have a scaling factor Fs between 0.5 and 2, we can say that the earthquake is appropriate and suitable for the analysis of the specific earthquake, the specific foundation soil. So according to these 4 criteria, we can form a list of appropriate earthquakes, and we can expect the maximum response. But in order to derive the design accelerogram, there is one more step, and it is extremely important because this is the deconvolution procedure, and it is related to the fact that in the geotechnical modeling, we usually use models where the ground motion is applied on the base of the model. If you actually the two of the figures explain that where is the free surface and the base of the model. The base of the model is several meters below the ground surface. Unfortunately for us, the big amount of earthquakes are recorded on the surface. And this is why the deconvolution is needed. Applying this procedure, we can obtain the ground motion at the base of the model. There are 2 main approaches to conduct the deconvolution procedure. The first one is which is presented on the left, is the frequency domain procedure. Here we have a one-dimensional solution of the soil profile. The ground motion is applied on the free surface, and it is presented by a series of harmonic functions, the Fourier series of harmonic functions. According to the parameters of the stratigraphic profile, we can determine the amplification function, and which actually explain how the future effects of the soil. And by multiplying the input ground motion and the amplification function, we can easily obtain the ground motion at the base of the model. Here, the big disadvantage of this model, this approach, is that we use elastic or at most equivalent linear physical model for representation of the soil, of the seismic response of the soil, which is not the most it doesn't represent the real response of soil. But when we talk about the time domain procedure, which is the better procedure, here we can use more complex constitutive model, for example, hardening soil small, to represent inelastic the response of the soil. This procedure actually includes some. It's an iterative procedure, and each iteration includes convolution and back deconvolution. And the goal is to obtain the factor F, the correction factor, which have and we have prescriptions for its values. So in order to explain and illustrate the proposed procedure, a construction site in Sofia in Gheomilă district is examined. On the left, you see the stratigraphic profile of the construction site. It consists of 2 layers of clays and 1 layer of clayey sand. On the right, you see fragment from a dominant frequency map where the construction site is pointed, and we can easily report that the natural period of soil is 0.75 seconds. According to criterion number 2, we have selected 7 earthquakes which satisfy the criterion for magnitude higher than 6 and focal depth up to 30 kilometers, which are representative values for the Sofia kettle. Here it is important to say that the epicentral distance is not included because there it is lack of available records which satisfy these parameters for the Sofia kettles. This is why we used earthquakes which has happened in other countries. On the right, we see 4 pieces of the accelerographs of the listed earthquakes. According to criterion 2, we can report that 2 of the earthquakes are accomplish this criterion. This is the earthquakes which are in blue graph, the Loma Prieta and Yerba Buena record, which is record for the same earthquake but with higher epicentral distance. We can see that there the difference between the 2 parameters is up to 16%, and for the other earthquakes we see difference between 30 and 60%, which is it is not suitable. According to criterion number 3, we compared the response spectrum of the earthquakes and the target response spectrum. It is on the left, we see that it is obvious that the spectra are not compatible. This is why we applied simple scaling, and according to criterion 4, the scaling factor for Loma Prieta earthquake is 0.63, which is lower than 2, and for the Yerba Buena record we have scaling factor of 2.34, which is higher of 2. So we can say that the Loma Prieta earthquake is the most appropriate and suitable for the analysis of the foundation soil and construction site in the Sofia in the Gheomilă district. And the last step is the deconvolution. Here the frequency domain deconvolution is applied. In blue graph we see the original signal, which is on the free surface, and with red line we see the deconvolved signal. It is obvious that the big amount of energy actually is lost exactly around the natural period of soil, and it is additionally proved by the amplification function, which is on the lower on the left. The maximum ordinates of the amplification function is actually around the natural period of soil. And on the right we see a graph which represents the variation of the peak horizontal acceleration, and it proves one more that when the seismic wave aims to the surface, the signal is amplified, so does the horizontal acceleration. Thank you for your attention.
Thank you, Maria. Very interesting presentation. We have enough time for questions. Are there any questions from the audience? Yep, microphone please.
Thank you very much. I just have one question. The last diagram shows the acceleration horizontally in different depths. What is the conclusion for practical application for building constructions there? I mean, you obviously have in different depths, different acceleration. So what is the consequence?
Well, when we design underground structure, we have to pay attention for this thing. Because when we talk about tunnels, for example, and they are on very big depth, the difference between the horizontal acceleration on the surface and on the depth can be very enormous, and it can change the response of the structure. This is why it is important to pay attention.
I also have a question. Are there any connections between the type of the soil and the land work? I mean, it's a bigger danger for the construction which are built on the banking of the rivers or on the hills or on the flat surface.
Well, thank you for this question. It depends on some parameters of the soil, dynamic parameters. So, because when soils are, as I said, they have inelastic response. So it is very important to understand how the stiffness is lost. For example, there are some degradation curves that they're not included there here in the presentation, which will answer your question. But for example, sands lose their stiffness with the bigger temps than the clays. So around the rivers, we can have clays and sands and gravels, and it depends on the parameters of the soil.
Thank you. Thank you.
Are there any more questions from the audience here or online? Go ahead.
Well, curious, you mentioned that depending on the soil type, I mean, generally speaking about soil, because it's not a soil, it's just, let's say, bedrock, even it could be. Because you have, I think, for here soil, also you have geological problems, especially for the Soviet case study. And you mentioned also that you have different acceleration, which is important for the underground structures. I believe this investigation is done towards the metro construction. No, it's not related to the metro. But how, let's say, depending on the different acceleration which you have for metro in this case, if you have a tube which goes through different geological structures, is accounted in the construction. Let's say if it goes through gravel, through sand, through clay.
You mean that the tube can go around different...
Yeah, because it basically goes through different...
Well, we can design the tube in sections in this case.
But is this any way accounted in the construction in practice? I'm just curious.
Well, this is why we conduct geotechnical model.
Yeah.
In which actually the model itself, when we examine the variation of the acceleration, which is can be conducted by the geotechnical model, not only by the decomposition procedure, we can see how the acceleration is varies. And depending on the acceleration, we can estimate what part of the mass of the structure is activated, which is an important thing.
I understand and
We don't have time for discussion now. You can continue the discussions after the panel. Please. Now we have one additional question to you, Maria, from our online audience. It's about what the role do ground motion records play in the development or design accelerograms for dynamic retaining wall analysis.
Well, I recommend to the audience to read my dissertation and he will understand.
Excellent answer. And if we have enough time, I think we have 2 or 3 minutes. I'd like to ask our gents, all of you three, about your studies. All of you presented supervised based training, modeling, algorithms. What about unsupervised modeling? We can start from you.
Yeah, of course, in our experimental part, I'm sure about the accuracy of the results, it was supervised, but it could easily go unsupervised the workflow. So from the collecting the data, analyzing and the output, it's easily accomplished in my case.
Okay, thank you.
Thank you.
Who is next? The professor or professor?
Okay. Thank you. First, I would like to thank the one from the audience for comments to my presentation and for the different other different methods to estimate bird population. And so I think that this tool that we create is help actually government organization in order to estimate the real population in my case, real population of this animal. So in the future, we will continue to improve this tool in order to estimate more precise this population.
Thank you. Thank you, Professor. Would you like to add something?
With regard to the unsupervised and supervised, well, in our case, we did not use any supervised or unsupervised algorithms, like just a statistical approach. But we used to use this supervised and unsupervised image classification, especially for corporate assessments. So it's common. But what's uncommon is let's say we typically use unsupervised methods to define how many classes do you have in a scene. Yeah, because you basically sometimes you don't know, you don't have a priori information how many classes do you have, and you just want to know how many classes. And then it's like a personal step, then you can go further with supervised classification.
Thank you very much, Nina. Would you like to add something?
I think that we're okay to go for a coffee. So let's conclude, and thanks again to our panelists.
And now it's my turn. Sorry.
Yet, I would like to give the certificate for Professor Todor Gurov.
Sorry. No, thank you very much. To Professor Lachezar Pilchev. It's here.
Thank you.
To Miss Maria Topolska. Thank you very much for this. And Kalina, I think, is the last one. I hope so. No? We have two more.
Yeah.
Mrs. Elena Blagovska. And finally, Elena. Thank you very much. And now we can go on the politics. Thank you very much.
We'll be back 10:45. next panel, we have two topics: disaster management and risk management and assessment. We have here three presenters, and Steve Recker will be the moderator of this panel. Steve, what is yours?
Thank you, Colonel. Good morning, everyone. Good morning, good morning. We're on the home stretch for finishing the conference. So very excited to see as many people staying and participating in the event as we have today. And I look forward to 4 excellent presentations. We have 3 presenters, but we will have 4 presentations. Before I begin, I'd just like to one more time thank the organizers from CMDR, COE, and from the Belgian Academy, Bulgarian Academy of Sciences. Thank you, Nina, for organizing the EnviroRisk portion of this. So thank you very much for that. And even if you're not from Belgium, from Bulgaria, I apologize. So with that, I'm going to go to our first presenter. So Dr. Boyko Rangelov is a professor in geophysics. He's a seismologist. So I look forward to focusing presentations on that element, working with Bulgarian Academy of Sciences and Arts. It's naturally his professional interest and expertise in seismology, natural disasters, risk and vulnerability assessment, and early warning systems. Boyko, as well, is a member of several editorial boards of scientific journals and organizing committees of international conferences. So very, very much pleased to welcome Dr. Rangelov. Boyko, please, over to you.
Thank you. I think it works now. Can you listen to me? Yeah. Thank you. So the first presentation is entitled The Integration of a Climatic Early Warning System to VG Alert. This means Bulgarian System of Alert. And some possibilities and difficulties of this possible integration. We are brought a team from different institutions. But in any case, we are doing this investigation since many years, maybe 20, something like that. Okay. What will be the content of my presentation? First, an introduction, then which aims we are following to do. The algorithm of model the kinematic system, seismic systems of early warnings, the algorithm of action of such a system, and advantages and disadvantages, I mean the possible connection with the alert system or troubles or obstacles to do this. So, just for the public to know a little bit more about the seismic early warning systems, there are several world systems. The first one in Pacific, established many years ago, last century. Then the Indian Ocean system, which was established after the tremendous earthquake of 26th of December 2004. There are some regional systems, early warning systems, for example, the Mediterranean one with leading Portugal, Atlantic Ocean together with some NATO countries. The last very attractive one is Indonesia, and some local systems, for example, in Crete, in Greece, and in some big cities, just for example, Mexico, Istanbul, Bucharest, some else. What is the aim of kinematic seismic early warning systems? You may see all these topics listed in this part, but I would just like to stress for some of them which are more important. The first one is to initiate the mass notification procedure, which is done by different ways. this is important for last years to send emergency messages through the mobile phones. Then some instructions, very simple one, but this is not always included. Sometimes it existed, sometimes not. And to try to protect some facilities using automatic cutoff or off systems to eliminate the possible secondary effects, negative effects, like cars entering tunnels, bridges, etc., etc., etc. To move some people away from dangerous machinery, to switch off some dangerous, for example, chemical productions, etc., etc. So, just for the people who are not very familiar with what means the kinematic early warning system, this is an example of a typical seismogram. You may see on it the so-called P waves, which arrive first in the any site. Then you have the second type of waves, so-called secondary waves, which are much more energetic. They have larger amplitudes and lower frequencies. And finally, some surface waves, which are included in so-called coda of the seismogram. So the fundamental relation which is used for the kinematic early warning system is the physical property of the P waves, which are propagating much faster than others. For example, faster than S waves of a degree of -1, 0.5. So what is important to know in such a system is that we use only the kinematic parameters, which means velocities, travel times, and distances. There are no amplitudes, which are frequently used, and frequencies as well, in other early warning systems, for example, in Japan. So this relationship between the time of the travel time of the seismic wave and the distance is called travel time curves, and they are in the fundament of these systems there. So on the left panel, you may see how it looks like these travel time curves for different types of seismic waves. So this is the relationship between the distance and the travel time. And on the right side, you may see how it looks like in the two-dimensional part. So you can make some cross-section in different times, and you will get this picture. It helps to select the place of the sensors, which you can use for the action of the early warning system. So, what is important from seismological point of view, the travel time between P waves and S waves, the difference between these travel times give you the possibility to estimate the distance to the seismic source. It depends, because this dependencies, as you said, as you will see the straight line. So what is the algorithm? First of all, you can read all these topics are there, not very, how to say, they're more detailed explained. I just like to stress that you have to deploy your sensors, and just a little bit later you will see how we did it in our model. But you have to have as possible as earlier detection of P wave, which would be a signal that earthquake. Yeah. So this is the stress point, this is the key point, that if you have an P wave registered, you have earthquake, and it emits other seismic waves, especially S waves. As I said, they are more destructive. So the most important thing is to have a mid signal that the earthquake happened. So here you may see the seismic sources from which are, how to say, dangerous for Bulgaria and are well known. The seismological society, they know exactly what are the most dangerous seismic sources on the territory of Bulgaria. There are 1, 2, 3, 4, 5, 6 of them. And also the outside source in Romania, around the Carpathians, which also can affect the country. So these distances are to measure to the operation center. This operation center is hypothetic. This is not really existing, but it just gives us an idea what are the distances between the seismic sources and the point we need to have a signal and to warn the population. So the next slide shows how long time you need to travel P waves from seconds from the sources to the operation center. What is important to mention here that is the seismic velocities, the seismic waves velocities are very high, between 6 and 8 kilometers per second. Please note these numbers, 6 to 8 kilometers per second. Okay, here you may see the travel times. I cannot see exactly the numbers because my glasses are not correct, but I can see about 60 seconds or something like that from the farthest sources. And from each, you can see, so the local sources have very short travel times, and that's why systems are not very effective for the near source field, but we will discuss a little bit later this topic. And this is the travel times of the S waves. When you have the B waves signal, you may calculate easier the time of S wave arrivals. And here, what is important to mention is that these times are about of 100 seconds, which is not very small time interval. You can take some measures for these seconds, even sometimes to protect your life. But this is more a technical, purpose to have disconnected all these dangerous facilities which we talked in the initial part. So how it works? First of all, you have to deploy the seismic sensors, which are emitting the signal immediately when you have a signal that the earthquake occurred. And from this moment, it starts to calculate the time. Much more important is that this first sensor indicated the seismic currents to trigger the whole system, and the whole system starts recording all signals which are coming later. P-wave signals, S-wave signals, surface wave signals, which then could be used for monitoring and recalculating the possibilities of the system. What are the advantages and disadvantages of this kinematic seismic early warning systems? First of all, these are low-cost systems. For example, in California, there are a system, everybody can buy its own sensor to connect to the network and to exchange the information, the data, if the sensor is detecting the signal, then spread it all over to where, and you can see on your screen that you have a message. Your site will be affected in 10 seconds, in 7 seconds, in 5 seconds now. And now you can feel the vibrations of the seismic wave. So this is the first advantage, that you have low-cost detectors, low-cost sensors, which you can deploy in the respective seismic sources. Then you have a relatively high reliability because always you have a good signal. I mean, the big amplitude of the P wave near the source, you have a signal which would be an indicative for the earthquake starting. Then it's easy to integrate to other warning systems, for example, climatic or weather warning systems, etc., and have an increasing effectiveness after expansion with more sensors. More sensors you have, more reliable is the work of your system. What are the disadvantages of these systems? First of all, I mentioned, but we will stress on this for now, that you have a very low efficiency for the short epicenter distances because the time is very short and there is no time reaction, for example. What is the most important, in my view, disadvantage? It is the lack of the legislation. You have no any law how to use these early warning systems, who take responsibility of the information dissemination, all these things which must be regulated by a law. Otherwise, we have a chance to get very complicated false alarms and no responsibilities about this, who is responsible to produce a false alarm, etc., etc. And what is the most important also, at least, but not very important thing, this is the people education, how to react in case you have a signal from the warning system. This is the most important topic in Japan. Before they introduce their early warning system in operation, they have 5 years education of their people. What means the signal, how you have to react, what we can do if you have a false alarm, etc., etc., etc. There are a lot of topics which are very important to be clear for the whole population to have the effective work of such a system. And what are the problems and obstacles? I'm going to finish, so you have to see them. There are some technical problems, for example, consistency of the hardware with the abilities of this PJ alert system, maintaining the hardware, who is maintaining this, who is paying about this, what are the resources of technical staff supporting all these things, etc., etc. The foreign experience could be very useful in this case because people are using such systems and they have enough experience to know how to manage this thing, etc., etc. I mentioned about the false alarms, etc. And what are the organizational obstacles and problems? First of all, the integration. You need the reconstruction of the philosophy of BG Alert because now it works after the checking the signal. What is suggested there is to have a smart sensor which takes decision instead of people and automatically distribute the message that you have to be alerted about the happened earthquake. And finally, we are mentioning again the obstacles, again saying need of legislation, distribution of responsibilities, who is responsible for what, consensus about the protocol and decision metrics, when you have to warn people and how you can manage this warning correctly, etc., etc., correct knowledge distribution about the population and so on. What is the conclusions? First of all, the algorithm for construction and action of seismic kinematic early warning systems related to the BG alert system are developed and presented in front of you. I mentioned the physical basis and the theoretical consideration, how it works. We saw all advantages and disadvantages of these systems. problems and obstacles about the integration of the kinematic system to the DG alert system, and so on. So, thank you very much for your attention.
Before we move on to the next presentation by Dr. Orlando, any questions on this first presentation? I have several. I will hold to after your second presentation if you don't mind. Very good. If we can then call the next presentation on the screen. Very good. Thank you very much.
Okay, thank you. So this is a little bit more, how to say, story presentation than scientific investigations, because a lot of things described in this case have been published previously and they are available publicly, so you can follow if you have some special interest in some topics. You can find the details in there. This is just to stress for some important things related to the northern Bulgarian Black Sea coast, and that's why it's called review. And just to mention some new discoveries made during the last years. Again, content, introduction. Then we'll have a look on the natural hazards map of Bulgaria, issued 1991. Then focus on Bulgarian Black Sea coast and natural hazard there. About the multi-hazard events which are typical for this area of Bulgaria. What data and information have been extracted during the years of investigations? What are the new discoveries and conclusions? So, what is important to mention that we have very ancient data about the natural hazards of the region. This is the most ancient information discovered in any place for Bulgaria. That's why it extended our knowledge since ancient times until to the present days. We will have a look on earthquakes, which are very strong in this area, but they happen in irregular way. Some active faults and their types, which have been investigated, and typology was constructed for them for the last years. Some information about tsunamis, landslides, because the whole area is affected by Sarmatian limestones, which are very sensitive to landslides. Also on land and turbidites in the sea. Some floods, but just mentioning that there were some surge storms, some sea level changes due to the meteorological effects. The storms, which could be windstorm and ice storms, which are happening every year in the northeastern part of Bulgaria. Water currents, mud volcanoes, metal seeps, and other natural hazards are this area. So what's seen there, this is a part of the natural hazards map of the North Bulgarian Black Sea coast and BBCT SC. So you will see the faults, the earthquakes which are mentioned by asterisks, the waves generated by storms or tsunamis, the loss collapsibility, and the landslides areas just around the coast, etc., etc. This map is available, but what is important to mention here is that this map was created much earlier than in any other countries in Europe. This is the first map integrating all geological hazards and some others on a map in a scale of 1 to 500,000. These are the mentioned already faults which could be different type. On the left panel, there are some real pictures from our last field trip around the coast, just near Kaliakra Cape. You may see the active faults and other effects of their activity. And on the right panel, these are mapped faults by different methods, in general geological, some borehole investigations, some geophysical investigations, etc., etc. And all these faults have been arranged in a special typology, so you may see how they look like, and they have been published, of course, and if you have an interest in it, you can find the publications about this. This is a typical example of a giant landslide, which is visible even today near Kavarna. This landslide happened 3rd century BC, triggered by an earthquake, and this part I can see. Can we make a pointer? Yeah. This is the area where this landslide happened, going down to the sea, and still is visible if you go today on this plateau where this Greek colony have been located these centuries, and the colony was moved from the plateau after this tremendous event. What is important for this area, these are also multi-hazard events, which are triggering one by another. So, for example, strong earthquake can trigger rock falls, or landslides, or turbidites if they are under the water, which can trigger tsunamis. Heavy rains can trigger floods and landslides as well, which happen very frequently in this area. For example, bottom gas seeps can be related to mud volcanoes, which also make sediments which are moving if you have some movements, vibrations through the turbidites, and even tsunami effects have been documented. So one of the most mentioned typical case for a multi-hazard event is a Cybele, or I don't know how to pronounce Cybele temple in Baltic, which is a typical example. And on the left side, you may see the picture made by above. And on the right side, the reconstruction of how many natural hazards destroyed these temples, which was existing since 3rd century BC until 4th century AD, even 5th century AD. So you have first fire, then you have an earthquake, then you have tsunami, which overflooded the floor of the temple. Then you have a landslide, which cover all remainings, and finally it was digged and discovered by the archaeologists. So what about some new discoveries which we made during the last 2 years expeditions in the area, together with Russian specialists? It was before the war in Ukraine. After that, these relationships were cut off. So the investigations discovered some seismic effects on Durankuak site, which is one of the most mentioned archaeological sites with long life over the island of Durankuak in this lake. So there many indications about the seismic displacements on the structures have been registered. I will show some of them. For example, follow the white arrows. They show the movements which were sealed, how to say, by the ancient structures. On the left panel, you may see this counterforce wall. On the right side, some rotational movements, and the angle part, this corner Maybe some more, yeah. What is important to say here, this is very hard to say specific activity. There are not very much specialists in this field, so we have a good chance to have a Russian specialist there who recognized all these things and documented all of them. What is important to say is that you need to have a systematic deformation. You may have deformation in many points, not only a single point. You cannot make your conclusions based on a single point. You have to have many measurements which are interactive, interrelated, and then to try to make some conclusions about these earthquake effects on the ancient structures. This is another example in Varna, so-called chromothermy, where also some effects of displacements have been documented. What is most important here? This is the dating. The most important thing is to have the correct dating, and the data have been, how to say, discussed with archaeologists. Seismologists are not able to date the effects and the events which produced the effects. That's why we need a very close cooperation with historians and archaeologists, which can tell which structure, when have been built, and how you can try to relate the data with the real happened earthquakes during that times. And finally, this discoveries which we did just a year ago, but it also was published. There is a recently disappeared island. It was located just in front of Avaja monastery. Most of you know where it is, in this area of Golden Sands resort. So, it was existing island, which now does not exist, no more exist. So this is a non-ancient map of 1648, which shows this island, which now is not visible. It is under the water, and probably the reason for this is the deep landslide which did this sub-water position of this. So finally, I'm going to conclude. I don't know how much time. Is it okay? Thank you. This is a review paper, as I said you. The described cases show large variety of hazards to the infrastructure and people living there. This is a tourist area, which is an important type of industry. And what is the general conclusion of this for me? This is the most dangerous part in Bulgaria to live there. Thank you.
Thank you, Doctor. Questions from the audience, please. I think there's maybe a microphone right behind you.
Professor, you are the first to make the multi-hazard map with the threats, the hazards in your country. In the future, you will make any map with the risk, the multi-hazard risk for the disasters?
Yeah, I think my phone is working. Yeah, it works. Okay, I'll try yours. Okay, yes, we are doing some risk mapping for all these hazards, but it is very difficult to include the multi-hazard map. So it's complete, how to say, it's very difficult. There is no common methodology to do this. But separately, as I know, my colleague from the National Institute of Geophysics did the risk map, the seismic risk map, especially for Varnsy, which is the most populated area, the most populated city in this area. So I think it's ready and already published. Nothing more I know about this risk mapping there.
You can pass the microphone up for you to, thank you.
Thank you for the very interesting presentations. Do you plan to integrate future scenarios of sea level rise, even if it's minor, on the coast, or changes in precipitation regimes which might affect landslides in the future? So, in other words, will you incorporate such potential future changes in your hazard map, or?
Yes, my short answer is yes, of course. My extended answer is that people who are following the measurements in the area are doing already such things. So there are, first of all, measurements of the sea level changes, and second, the activity of landslides, installing some instruments there. That's what I know.
Thank you, Doctor. Other questions from the audience? Very good. Thank you again very much for your presentations, both of them. Again, I have several questions, but we'll see if we have time at the end, if you don't mind. If I may now, I will turn to our next panel member, Dimitar Nikolov, who will talk on climatology of freezing precipitation in Bulgaria. If we could call up the slide presentation, please. Dimitar, is that microphone working for you?
Everybody.
Here we go. I'll pass you mine again. Let's try that.
So, my name is Vincent from the National Institute of Meteorology and Meteorology. I'm going to talk about monitoring of freezing precipitation.
Here we go. Let's try this one again. This one, that one again, and this one's on.
So, hope you can hear me now.
Still not. Okay, let's.
So I'm going to talk about this type of freezing precipitation, but I hope you hear me also without this microphone. So, what was the motivation of this study? Let's try it really. So the motivation for the study was that the ice storm caused by severe freezing and drizzles are among the major weather hazards in winter. And as Professor Andrew mentioned, in northeast Bulgaria, they happen each year. And this type of precipitation may influence seriously the air, the ground traffic, and disturb and even interrupt the distribution of electricity, or bringing even to standstill the production from wind farms. Most frequently, they are observed in mid-latitude, as in Canada, USA, some part of Finland, but even in some southern regions in Europe, like Bulgaria. Although such events, severe events, are relatively rare, they cause some of the highest damages caused per event. And the most important motivation was, despite their severity, no comprehensive climatological investigation of these types of precipitation in Bulgaria has been made so far. That's why we decided to summarize our findings for the last 30 years. The main goal of the study was to estimate the following characteristics of freezing rain, precipitation, to estimate the mean duration, mean number of days or events, and typical values of the meteorological variables during such type of events. We have used data from 38 meteorological stations, which have regular 8 daily records for the period 1991-2020. We have excluded the mountain stations because this type of precipitation is not typical for mountain stations. And we have used data from Area 40 for one case study of the most severe events in our data in 1998. So there are mainly two mechanisms for development of freezing rain and freezing drizzle. Freezing rain develops with warm layer above and the sub-freezing layer below, because the precipitation is developing in form of snow particles in high altitudes. Then it melts in the melting layers, and finally it will become supercooled in the surface layer. The other mechanism is the freezing drizzle mechanism, which means Colin's mechanism or warm rain. In this case, the cloud droplets develop directly in liquid phase, and there is no warm layer needed for developing such type of precipitation. And the other type of freezing precipitation, it's actually already frozen precipitation. These are the ice pellets. They have developed in the same way as freezing rain, but in such cases, the surface layer, cold layer, is much deeper, and that's why the melted droplets freeze completely in this layer. They don't possess any threat, but belongs to this type of freezing precipitation. That's why we have included also them, and they are an indication also for a potentially dangerous situation for freezing rain. So, as mentioned, the most severe cases happen in Canada and USA, northeast part of USA, but occasionally the worst cases in both regions in Canada and USA and in Bulgaria happened in 1 year, 1998. In January, it was the worst cases in America and Canada, and later in this year, in November, it happened. Such case happened in Bulgaria as well. So here are some results. Finally, we present here the duration of the freezing rain and freezing drizzle combined both cases. This map represents the duration of the events in minutes, and we see that the most affected regions are in northern Bulgaria, especially the region of Dobrich, Razgrad, and Shumen, where the freezing rain process can last for more than 2-3 hours, and in severe cases of 6-7 hours. In South Bulgaria, the cases are very rare, so this estimation here of duration is not very reliable because it is based only on a few cases, but however, we have plotted on the map. Then we have estimated the number of days with freezing with glaze, which include both, again, freezing rain and freezing drizzle. This is presented on the left panel of the maps. And on the right map is presented the spectrum distribution of the ice pellet. We see again that North Bulgaria is most affected for freezing rain. Most affected regions are again in Razgrad and Dobrich, and some part in Prața and Montana to the northwest. Ice pellet almost repeat the same spectrum distribution. Here we have estimated only the cases which were assessed by the observer, this means subjectively, as severe places. And it is also one confirmation of the feelings that northeast part of Bulgaria has the most severe cases in these events. Unfortunately, we don't have the data. We have the data, but it's not in digitalized, and we couldn't work on it now for the period before 1991. The old cases in order to compare the situation with the previous period. But this is one of our further investigation. He has presented the wind speed and wind direction during such events, and he has presented the station from North Bulgaria because of the same reason. The station from South Bulgaria doesn't have enough data to make such statistics. We see that in most cases the wind is prevailing from north, with some exception from northeast, mainly under coastal region. And wind speed is not high during such events, except when the event ends, then it happens that very strong cold advection happens with wind gusts up to 20-24 meters per second. In this table is summarized these typical meteorological parameters. We see that the mean air temperature varies in a narrow interval, which is typical for such events, up to minus 4 degrees below zero. Wind speed is again not strong. And total precipitation amount during freezing rain, but this is not an exact estimation of the freezing precipitation amount because they are not separated in the measurements. This is daily amounts in cases of freezing rain. It's again not so high except for severe cases. And here we have investigated this. Most severe cases during the period in Bulgaria, 13 November 1998. We used here data from ERA 40 in a previous not published study. And on the first map on the left, we see the frontal lines during this event. Then on the next picture, we see the typical meteorological values, the fields. The blue one is the wind speed field for 2 days in this event, and then the temperature in the next 2 days. So, and here from station Asgard, we have used the data for increasement of ice deposition measured at this station to the left. Actually, this event was comprised by 4 separate weather events from cyclones passing south of the country, which caused 4 separated in process of freezing precipitation. But in this case, the curves below depicts the air temperature, and we can see the mean air temperature during the day. We see that it didn't rise above 0 degree except for one in this case. That's why the cold deposition lasted for more than 10 days, accompanied by a strong wind. That's why it caused severe damage on the network system, electric network system. We have estimated here for Asgard the air temperature, the mean of the minimum air temperature, the blue line on the next the graphs to the right, and the average from the absolute minimum temperature for this station for the period 1961 to 2018. And we have here significant increasing trends at level 005 of increasing temperature. This imposes a conclusion that such rare events with long-lasting ice position will not happen so often in the future because of the tendency of global warming. On the next graph is presented the duration in the same station from Razgrad, the mean duration of such events and the number of days of cases in the same station, we see here decreasing trends. They are still not significant, but here the period is shorter. All this support the conclusion that such events will be probably not so often in the future, according to the temperature conditions. So then I'm coming now to the conclusions. So most affected regions by such types of precipitation are in the north part of Bulgaria and especially northeast part of the country. Freezing precipitation in ice periods are short-lived, with greatest mean duration between 150 minutes, but in other cases it can reach up to almost 6 hours, only the process of freezing precipitation. And this event usually occurs with low winds, but after the end of the process, speed may increase significantly, and the duration of a single process and the number of days with freezing precipitation decreased in the last 30 years, but still not significantly. And so that's why we need to extend the period back to 1960 in order to receive better assessment of all characteristics. Unfortunately, this data is still not digitalized and always written only on paper. And the recent global tendency of warming imposed that lower threat from freezing precipitation. But I have to mention that last November, we have a very severe wet snow event, again a part of the such icing events, and despite the global warming, it seems that the cases of wet snow events are increasing, which can serve as confirmation this last event. It was short-lived, but have caused serious damage in North Bulgaria. And so, thank you for the attention.
Big questions. Good, thank you. Thank you very much, Sutan. Very good. Last one again. Hold on. Thank you. We'll look both microphones. We'll see which one works in the given moment. So thank you again for the presentation. I have a question from the online group first. We'll go. Then please, if you have questions from the in-person audience, let's do that. So the first of two questions, how does the geographical diversity of Bulgaria affect the distribution and frequency of freezing precipitation events across the country?
So we have depicted in the map that in north part of Bulgaria are the most severe cases, especially in North Bulgaria, there are only occasional cases, freezing rain and freezing winter. This is because of the geographical distribution and the relief in Bulgaria. We have the mountains territory which hamper the cold affection to the south, and that's why this cold area is developed only in North Bulgaria. It favors only also the development of the second process, the cohesion tolerance mechanism for freezing winter in North, especially Northeast Bulgaria and Razgrad. So it favors only the freezing precipitation in North Bulgaria, especially in Northeast Bulgaria. Second.
Yeah, see if anybody in the audience here before I go to the second one question. Anybody present have a question? Very good, thank you. The second question then for you, Dimitar, what are the main challenges in predicting freezing precipitation and how can forecasting models be improved?
There are a lot of efforts in this direction and also some schemes are developed. mainly are based on this typical temperature profile with the warm layer for freezing rains, also for freezing drizzles. Forecasting scheme developed now. Not exactly in our institute, but worldwide. We are planning also to implement such forecasting scheme, not only based on physical parameterization, but also on a stochastic model. As, for example, my colleagues yesterday presented. Make presented a forecasting model for fog, the airport in Sofia. We are planning to do similar approach, to use the similar approach for freezing precipitation, not only so physical forecast, but also practical.
Thank you very much. No further questions? We have one. So, Ryan, please.
Okay, I speak loud. You predicted a decrease in the probability of these events. I understand that. But would you assume that then the magnitude or the severity increases due to higher evaporation, for example? Okay.
Yeah, thank you for the question. Yeah, we are assuming the decreasing of the probability for occurrence of such events, but not for their magnitude, because it may happen that the duration will be shorter, but the magnitude, the intensity of the process will increase, because what you have mentioned, the increased value in water vapor in the atmosphere, it depends, it may lead to more intensive rain intensity. So far, the intensity of such rains is not so intensive. They are usually slowly developing process and short-lived, but for now, we're expecting only the duration to decrease. We cannot assume anything about the intensity. Probably we need more information, more measurements as well, and more detailed measurements, because we have to separate only this type of precipitation intensity from the other precipitation intensity. They are embedded in one long-lasting process, for example, but it starts as rain, turns to freezing rain for several hours, and then finally it ends in a snow process. That's why we have to make more detailed measurements in our network in order to separate exactly the intensity of such events. But we may assume that if, for example, this is only a working assumption still, but for the wet snow events in recent years, we observed that they are more intensive. They lasted shorter, but the intensity of such events are much intensive, and that's why they lead to more damages and to more regions which are not typical before for wet snow conditions. But we are working still on that. That is not still published.
Thank you. I think maybe if we have time, maybe during lunch, we can connect and follow up on that. So several questions, I think, worth following up on. So thank you, Dimitar, one more time. Next, in our final presentation for this panel is Dr. Luba Dimola, who has extensive experience in the field of physics of the ocean, atmosphere, and Earth space, and focusing on numerical modeling of tsunami waves in the Eastern Mediterranean. And coming from Hawaii, tsunami waves are something near and dear to my heart. She works as a research assistant in the Department of Meteorology and Geophysics, Faculty of Physics of Sofia University. Welcome, Luba, and over to you, please, for your presentation.
Thank you very much. Yeah, usually I present something on tsunami modeling, but now I will focus on seismic source modeling. So this work is together with my supervisor, Emmett Raikova from the State Department, and we will take a brief look into a series of two earthquakes happened last century near Plovdiv and Chirpan area. So the outline of my presentation short introduction with the main characteristics of the events, what data we used, and the methods. We are lucky that we have some geodetic measurements at that time, and I will show you some modeling using the Okada method. Then I will go to the test and some results and the conclusions. So here you can see maybe very popular historical photos of these two earthquakes. So the first earthquake happened on 14th of April 1928 with estimated surface magnitude between 6.7 and 6.9 for the event in Japan. 4 days later, another strong earthquake happened near Plovdiv with estimated surface magnitude between 6.9 and 7.1. You can see how many collapsed buildings. There were more than 70,000 destroyed buildings, more than 100 casualties, and more than 1,000 injured. So you can see the railway, how was deformed after the earthquake. And here in the next picture, actually this is the surface displacement. The surface breaks that were evidenced at some places. We can see more than 2 or 3 meters at some point. So here, this is a map of our study area. On the top left is the Balkan Peninsula, and the rectangular marks the area of interest. We have this geological map. The red lines correspond to the active faults that are described in the European database of seismogenic faults. The green lines determine the observed faults at that time. The interesting here is that in the European database, the fault that corresponds to Plovdiv observed fault has south-southwest dipping direction, while in the observed one is exactly the opposite, northeast. So with the yellow dots are described the epicenter locations for the Plovdiv event for the second one, while for the Japan first event is with pink dots. You can see that the discrepancies and the uncertainties are very large. This is normal, maybe because of this event is historical one. Here you can see the focal mechanism of the two events. They're collected from several papers. Of course, again, we have some quite different solutions for both of them. The last column is the reference model that we use in our study. So about the geodetic measurements, as I said, these events are quite unique because leveling data was collected before the events in the early 20s in the last century. Later on, between 40 and 59, again it was supplemented. Later on, it was upgraded with GPS data. So in total, we have cosmic deformations for more than 340 data points, which is amazing. So detailed descriptions about surface structure can be found in this large document that is prepared by the National Commission for the Mitigation and Seismic Damage by that time. And so what we did was to digitize this data. We chose 6 profiles from this paper. You can see many points on these profiles, and the picture on the right above, there is a displacement values for each profile. So the aim of our study is to compare the geodetic measurements with the model that we constructed, and we tried to find the best fit for the measurements. So this is the output from the digitizing the points. With the points color coded from blue to red, you can see the measurements. Again, the observed faults are with black lines, and we built this interpolated displacement field that describes quite well the measurements, but this is kind of obvious. So, yes, the Okada method that we use actually is perfectly described in this paper made by Okada. Actually, he presents a complete set of solutions for a finite rectangular fold for any depth and any deep angle in homogeneous elastic space. So the solution depends on several parameters. The most important one is the focal mechanism of the geometry of the fold, and the position of this fold. So here is a simple representation of the strike, dip, and rate angle. We can say that the strike angle is measured from the north clockwise. The dip angle shows the orientation of the fold, and the rate angle is measured opposite counterclockwise from the strike angle. These are the ranges for the three angles. Sometimes you can see that the rate angle, you can see in the literature that sometimes it's with a negative number. For example, in the model that I used, the model doesn't accept negative values, so I converted them into the range between 0 and 316. And here on the right are the basic movements during folding. The top panels show left and right strike slip folds, where the horizontal movements are predominant. The bottom ones are the normal and reverse dip slip, where the horizontal movement prevails. Of course, in reality, the earthquakes, they consist of both horizontal and vertical. So first we made some tests. This is one boring table probably, but I'm just going through it. So the first line corresponds to our reference model. X and Y correspond to the coordinates, geographical coordinates of our upper border of the fault. Then we have the focal mechanism, strike, dip, and rake. And then we have the geometry, length, width, and displacement over the fault. Then we computed the seismic moment according to the formula showed in the column. On the left side, you can see that I mentioned the range for surface wave magnitude, but we converted it to a moment magnitude because it's more convenient for us. We used formulas that are tested for Balkan Peninsula. So, according here, the second relationship between the moment magnitude and the seismic moment, we estimated the seismic moment for this earthquake about 1.26. And the most right column is the cosmic vertical displacement that comes after the local calculations. We can see that maybe here is better. The maximum displacement that we get is when we use tangential slip from 0.9 meters, which is like 0.2 from the reference one. You can see in the middle the picture with the values for the reference model. And you can see a massive positive displacement when the dip is about 75 degrees. So here are the differences between the reference model and the tested values. As expected, when we change the strike, the direction of the fault, it's normal to have the maximum differences, because when the reference is here, for example, you have some value. When you change it, the previous values are zero, so we have maximum. So we did the same for Plovdiv. I forgot to mention that from 1 to 12 are the 12 different parametric tests. So, for example, we changed only the strike, and then we stay with all the other values from the reference model. So in this example, we have the maximum seismic moment when the length of the fault is chosen to be 50 kilometers, and we have a minimum seismic moment when the width of the fault is about 8 kilometers. These are our results. Maybe they look quite similar, but we can say that there are some differences in surface displacement. If you change the dip angle again, you can see if you lower the dip, the formations are quite smaller. And of course, if you change the length, it's visible that it enlarged the displacement. Here are the differences again. It's interesting that here the rake angle is quite different from the two parametric tests. So after these parametric tests, we composed a more complex fault model that contains 7 segments. 4 segments are for the Plovdiv event and 3 for Chirpan. For each of the segments, we chose different geometry and different strike, dip, and rake angle. So these are our main results. The yellow lines represent the segments that we used. You can see that there are some discrepancies between the measurements and the model. For example, the first segment of Chirpan, which is the eastern part, the eastern fault, some of the positive measurements actually lie into our negative values from the output of the fault. There are many reasons for that. For example, this could be because the real fault is more complex than the model one. Of course, there could be some during the measurements, there could be some errors, instrumental or, and of course, while digitizing the dots from the other paper could benefit to this discrepancy. But in general, we're quite, we can say that we like these results. So to conclude, we tested many fault mechanisms and geometry in order to create a model that best fits the observed seismic vertical deformations. In total, we constructed 24 parametric tests for both of the events. And also, we constructed a composed fault models that consist of 7 segments with different geometry. And our opinion is that it reflects quite well the geodetic measurements and the deformation fields. And in general, we think that this methodology can be applied also to find more realistic focal mechanism, especially if we combine radar satellite data and prepare interferometric images. Of course, this is for more recent earthquakes. And yes, with this, I would like to thank you.
Thank you. Thank you, Doctor. Any questions from the audience? We're just about at lunchtime, but we still have time for questions. We always have time for questions. Good, good. Well, as we wrap up, then the penultimate panel. We have one more after lunch. I have just a quick summary I'd like to provide. So first, my takeaway from all of them is we're looking at the science to help us understand how to predict and then plan for events, whether it's freezing rain or whether it's seismic activity. Boyko, you talked significantly about early warning systems, and a couple of key takeaways in your first presentation were that there's a lack of legislation to help us integrate into the EG alert system, and there's a lack of public awareness and training, something that we can work on. And I think as a system here, we can work on that. The second part was the summary of the North Black Sea hazards. My response to that is clearly a very dynamic region. And so again, my question we don't have time for now, though, is really on the tsunami and flood early warning systems in that region and how those might be integrated into your first presentation with the overall early warning system. Dimitar, a very good summary of the 1998 events. Reiner asked a question about climate change, essentially, and how we're thinking about modeling for future events and predicting impacts. Again, that's something perhaps we can take into the lunch session for additional follow-up questions. And then the case study, Luba, of the Tripon earthquakes, very useful, kind of summarizing how we can understand the science to help us again look for predictive analysis. So thank you all. A very, very interesting panel session. I look forward to a lunch where we can follow up with additional questions. But with that, thank you very much.
Thank you. I would like to give our certificates of appreciation, Professor Boyko Rangelov. Thank you very much. The next one is Mr. Dimitar Nikolov. And it's the Associate Professor Luba Dimova. Okay, thank you. Yes, thank you. Maybe you can change the certificate, please. Okay, thank you. And now we have a lunch outside and we will continue at 1300. 1300. Okay, thank you.
Okay, let's start. So, good afternoon, everyone. I hope you have a nice lunch. So, we are at the very start of our final panel. I'm Boris Genov, an expert in the CMD COE. So, I will open the floor for the last entry of our conference this year, and would like to say some words, but unfortunately, my expertise is a little bit far away from what we're gonna talk. So that's why I'm giving the floor first to Professor Future to present our first presenter.
Okay, I'm Fidelio Future.
Oh, sorry.
Okay. The first presenter is Roger Fuchs. He is professor, the head of the remote sensing and KISS department at the Space Research and Technology Institute at Bulgarian Academy of Science. He holds his master degree in physical geography and landscape ecology. I think it's enough.
I think.
Okay, now we wait for the presentation.
Look, this is of Christo Children.
It's the second one.
Just a good watch.
Actually, it's with
Я именно презентацию стану отлично правильно. Я фигурирую. Добре, няма проблема, аз мога да изнеса. Аз да кажа, докато включат. Okay, regarding the presentation and the paper which was submitted for the proceedings, it was an old idea of mine which I basically followed up until now, to make a recap or let's say a systematic review of remote sensing applications within the climate change research. Although it seems quite, how to say, apparent or obvious that we have remote sensing, it's not quite there due to the fact that we have many applications, but in which domains and how they are structured and what are the main research lines also. It was interesting to me, especially to see how many different applications we have within this domain. And moreover, as you know, IPCC, the International Panel for Climate Change, Intergovernmental Panel, sorry, I was corrected, for climate change, is going to hold its 64th plenary soon in Sofia, so in the end of July and beginning of August. I didn't make that on purpose, it's just a coincidence, but so to say, it's a nice, let's say, kind of introduction to remote sensing applications towards this topic. And we have released already evidence. So I'm not going to read along all that because it's quite long, even as a paper. Actually, it was deemed as a chapter, and I'm so grateful that we weren't rejected due to the length because it's quite long. Initially, it was developed as a chapter, and we were thinking of splitting even this into a few other papers, but it's not that true, so we submitted it as one submission. Of course, as an intro, remote sensing, you know, some of you, maybe you don't know, but overall this is the science, and someone call it an art, because it's a cross between using the technologies for observing the Earth. In a particular case, with remote sensing, we have also for the planets. So you can make remote sensing also for the planetary systems. Is useful for climate change research because it offers a comprehensive view of the Earth's surface. Some of the instruments offer global view, some of them offer local view. It enables also the observation of the climate system. So some of you are probably meteorologists, climatologists, and you know that before those systems in the beginning of the 60s of the 20th century, this was like impossible, or it was hardly difficult to even imagine how the entire climate system looks like in one view. So to skip that lengthy introduction, here is just a list which we try to populate from all the domains which remote sensing helps in the climate change investigation. So we have global temperature trends, detecting changes in solar radiation, monitoring aerosols, studying the dynamics of snow extension and ice cover, monitoring sea level changes and coastal modification, monitoring vegetation status and change, water resources and impact due to droughts, fire events, disaster risks such as cyclones, etc., and guiding decision-making processes on climate change adaptation. So basically all of the aspects you can tackle with remote sensing, but not like a center of the research, but it's a significant help towards those directions. And again, about the importance, I will not stop here. You can read it then in the proceedings. So overview, as I mentioned, remote sensing is science and art of using the remote sensing technologies towards applications of various nature towards, let's say, natural phenomena, human-induced phenomena, etc. Overall, we have passive and active if we want to split the technology in two, concerning the way how the sensors acquire information. It's passive if we use the reflected radiation, backscatter radiation from the objects, or active if the sensor itself emits the signal and the backscatter signal from the object or the surface is received again by the sender. So, yeah, how the satellite images specifically can be used. They are, of course, widely used. I'll also not stop over here because we have also other presentations. And the investigations of the global temperature trends. So we start over already with different lines, which I read initially in the list. So we have here the global temperature trends, which it's apparent that they're used for. But the issue with the remote sensing data, although it provides global view, is the short, let's say, observation period. We have civilian remote sensing satellites such as Landsat since 1970, the beginning of the 70s, and on top of that, Landsat doesn't have complete global coverage in terms of thermal data, especially since probably the late 80s they had thermal infrared band. But the meteorological satellites are, as I mentioned, are starting much earlier in terms of global coverage. So we have GOES, we have Meteosat, then the European and all of the American satellites, meteorological satellites. So slowly and gradually,
Three generations
already, yeah, of EUMETSAT satellites, and so this record is slowly and gradually built, and completed with more and more accurate data. With regard to detecting changes of solar radiation, we can for sure also track down this parameter. With regard to the aerosols, so for each of those sections, we try to scan at least for the last 5 to 10 years applications, not to pollute the paper with too much information, especially redundant or irrelevant. Otherwise, it will not be a chapter for the entire book. So we mentioned here the climate change reports discussed, as well as a study from atmospheric measurement techniques with regard to sky level. And again, some applications of MODIS data. MODIS is already quite long, let's say, even quite old radiometer from NASA. It has more than 20 years of record. It's one of the good examples of how the remote sensing data can be used for various purposes. Also, we mentioned here another application for the seasonal dynamics of algal and bacterial communities in the Arctic Sea. But for sure, these studies are populating with, like every year, they're getting more in terms of frequency, citations. But due to the fact that remote sensing is more and more readily available, it's free. The data is very important. It's very important, as my colleague says, because until 2009 we had something like total embargo, but we had a paywall. So if you want to use some of the data, you should pay. Since Bulgaria especially become a EUMETSAT member state, we have this data, especially for the meteorological satellites, available for our researchers, research community, of course, also the general public, because it's a national membership in EUMETSAT. But overall, we become part of a bigger community towards the investigation of coordinate system. And with regard to the sea level change, here I mentioned some other papers, such as, even as you can see, published in the Journal of Plant Ecology, so, and the current landscape ecology reports. So another observation which can be made is that climate change research is more and more like acknowledged and published in different journals. It's a hot topic already. So, as you know, it's also a topic of political interest. So it's getting more attention, which is good, especially to my view, because we see that the climate is changing. Some of us can say, okay, this is, I mean, everyone can acknowledge that, but we should know exactly how the trends are moving. And especially those trends with regard to sea level change, not because, let's say, Bulgaria will lose territories because our coastline is not so, let's say, flat, but some islands, let's say in the Pacific, which are just 1 or 2 meters above the sea level, have an issue already with the sea level change. And the last highlight, so I think from the list, is with regard to the guiding decision-making process and climate change adaptation. So we have here again examples in MODIS. As well, here also the Sentinel data is already used for monitoring of polar ice sheets. We can say, okay, why we don't have that before? Due to the orbits of the satellites, we have difficulty to observe the polar system, the north and south polar system. So the satellite has to be exactly positioned in such an orbit in order to get capture the polar caps. Moreover, the radar systems, as you may know, they penetrate the cloud system, which means that they can acquire the dice sheet coverage even regardless of the cloud cover. And we have here also climate-related hazards tracked down and vulnerability assessments. All of these are just like highlights. In the paper we have references, that stuff. So yeah, so it continues with the local resources monitoring, droughts, fire events. All of that are just aspects of the climate change, and it's kind of peculiar and interesting. Here in the presentation, it's not so well represented, but it begins with the fact at exactly which IPCC report remote sensing is starting to become more and more like crucial in terms of data for feeding in the models. And in the beginning, it's just like you have cautious use of remote sensing data, whereas now in the IPCC reports, you have like almost like mainly remote sensing data. It's a backbone for the modeling and especially more complex models which require global coverage. Yeah, with regard to the disaster risks, here are listed few examples, especially the SAR technologies. Why SAR technologies are so important for disaster risk? For instance, we have a flood. Typically, I'll just not keep up with the slide, let's say, remarks, but I'll just give you an example. If you have a flood, typically this flood is due to atmospheric events, so you have a thick cloud system, you have pooling rain, and of course you have a flood event. In order to get a situational awareness of what's happening there exactly on the site, you need to penetrate those cloud systems. Again, an active system is a must. So you need to have an active system to penetrate the cloud system in order to see what's the extent of the flooding. And only after that, after the clouds are cleared, the meteorological situation is changing, you can get some optical data and assess, of course, the damages, which is typically happening, especially big flooding events. And maybe some of you know that for the disaster risk in response, even some private companies release very high resolution data to assess those damages. But this is quite an effort because damages are typically a lot. So you might have encountered that you have websites where people can actually participate themselves and they can assess the damages through, let's say, community effort, or let's say, even you can use some crowdsourced data. Of course, as I mentioned, for the flood, you can also assess the risk and drought anticipation through vegetation indices. You can see some moisture level, water reservoir. These are just examples. You can find this with actual references inside. Yeah, with regard to the agriculture, the adaptation strategies, for sure, vegetation indices play a crucial role, but they're extending like every year. 10 years ago, they were like 150, now they're more 200, probably 250 vegetation indices. So the community, remote sensing community is constantly adding the new vegetation indices to assess different parameters of the climate and vegetation system. And as you know, you have essential climate variables, ECVs, so maybe you have to encounter them, and most of them are basically assessed through remote sensing data. Yeah, I hope that I'm not repeating myself here. No, this is for the ecosystem and enhancing disaster resilience. Because I feel that I'm ahead of time. So finally, we have the future uses. So all of this paper and report finished with the future use of remote sensing in climate change. We try to highlight and extract 8 uses. So we highlighted we rely more on enhanced spatial and temporal resolution, integration with AI, so artificial intelligence and machine learning techniques, expanding data sources, which means we need to include unmanned aerial vehicles, because even now, maybe you know, maybe you don't, there's still a debate within the Copernicus program, which is the European Commission program, whether or not the unmanned aerial vehicles are part of Copernicus or not. It's still a debate. Sooner or later, this will be probably part of the Copernicus in terms of data provision. But for the time being, due to the sparsity of those observations, it's not like an operational component. Of course, we should rely more on data fusion techniques for multi-sensor data. So multiple sensors we can integrate. Of course, we rely more also on better climate change modeling. So it means what we have climate change models, but we need data simulation of remote sensing data more inside those models to get better results. Extreme event monitoring, so some of my colleagues probably know better than me how important is that. Carbon cycle monitoring, since 2018, the national reporting of greenhouse gas emissions from natural sources, especially also from the anthropogenic, through a regulation of European Commission, is suggested remote sensing data to be used. It's not mandatory yet, but still, most countries are suggested to go to Tier 3, so higher level of monitoring using remote sensing data. And finally, Arctic and polar regions, for time being, we just accomplish some information in the media, like we have this glacier which is calving, this glacier is melting down, etc., etc. These are sporadic information, but we need systematic monitoring of polar regions, which will give us a better picture of how far and how worse is getting the climate change in terms of increasing the global temperature. So thank you for the attention. And if you have questions, I hope that I can address them. Otherwise, all of your questions can be addressed by the paper. I don't claim that we are comprehensive in terms of like we, let's say, cover all the aspects, but we tried as much as possible. My colleagues can also criticize if they see. No, okay.
Maybe a small comment.
Yeah.
Hence, I am a dedicated user. I speak enough loud. I'm a dedicated user almost every week of satellite data. I can state that this is completely true, what you say. Only a couple of facts. Due to some estimations, the gain, the pure social gain, financial gain from the EUMETSAT second generation for early warning of meteorological disasters only over UK is estimated over 10 milliards of euro or francs. It doesn't matter, more than 10 milliards. And second one, in the previous year, I tried to estimate the onset and cessation of the disaster storm over the villages in the Karlovo region by means of the GPM mission. Do you know it? The Global Precipitation Mission. It's a global collaboration led by NASA. This is a new generation of satellite meteorological radar. I was very happy with the results. It's this high accuracy with the estimation of the onset cessation of the event, and even of the quantity of the precipitation quantity. And this is completely free of charge. Everybody, without any intermediate bodies can access them. Through Copernicus site, through the EUMETSAT, and the different satellite application facilities of EUMETSAT, and through the marvelous, I can say, marvelous data sites of the NASA, of the US NASA. And finally, the expectation, I was on the 2 years ago in Darmstadt, the headquarter of EUMETSAT, the expectation of the third generation of EUMETSAT are extremely high.
Thank you, Wade. It appeared to be a joint presentation already, which is really nice. Thank you to my colleague. So I believe, do we have
just like a bridge from what Mr. Chevenko said is there is an online question. It's about what are the best practices for validating and calibrating remote sensing data used in climate change studies?
Well, given the breadth of, and it's fine, right? If you separate. Yeah, so it's quite broad answer as well. I'll try to narrow it down to, let's say, that it really depends on the data itself, but if you have a specific product developed, of course you have to calibrate and validate with in situ. It depends on the in situ component. And with regard to EUMETSAT and especially those type of satellites and even Copernicus, the in situ component is maintained by the European Environmental Agency. So we have a dedicated network which basically take care of that for the land components. So for the land applications, we have LUCAS, which is maintained by the GRC, and LUCAS component is also evolving due to the fact that more and more requirements are imposed on how additional data we want to get. And one thing should be considered that you want to validate those satellite products, but it's costly. So you need to extend those networks in terms of funding. And the national governments and also European Union are also trying to save money on those observations because, otherwise it's inflating a lot in terms of costs. But we cannot use remote sensing data straight. This has to be known without validation information.
So, okay. And we should proceed ahead. Giving the floor to Professor Fidanova just to present our next speaker.
The next speaker is Hristo Chervenko from Institute of Meteorology and Hydrology. He is a physicist, specialist in meteorology, and work in the field of climate change and
applied meteorology, regional climatology.
And so on. Now it's your.
Thank you, Professor Fidanova. Actually, I'm head of the section of climatology in the National Institute of Meteorology and Hydrology, but I will not speak now about the regional climatology or the climate change, which is at the top of the interest on the broader, for broader social groups. Actually, our presentation now is more specific. This is in the field of the applied meteorology, namely about our preliminary results from the exploration of the wind model Wind Ninja on the local scale over Bulgaria. Actually, this is common with some application for the fire spirit. This is a common work with my colleague Цветан Dimitrov. Така. Yes. First of all, the outline of the presentation, of course, introduction and some preliminary words about the problem formulation indeed, the strengths, theoretical background of the selected numerical tool, the methodology, the use data, and the performed calculations. The core of our presentation is in point 4, namely the obtained results. Summary, conclusions, and outlook, and finally, of course, the acknowledgement. We will speak about wind, as this term was already mentioned, the essential climate variable, namely ECV. The wind is, out of any doubt, essential climate variable, key environmental factor affecting many processes in the low, medium, and even in the high atmosphere. And near the surface, it's subject of interest of experts from many fields. And regardless of the specifics of each task, in most cases, the data from direct measurements are not available for the certain point of interest. Indeed, the satellites can deliver some information, but usually the products which are connected with the wind estimation with the satellites are for much higher heights in the atmosphere, typically say of 10 or more kilometers, which they are based on the passive tracking of clouds and etc. And near the surface, the question is very tricky, I can say. For our country, additional difficulty is the nature of the traditional, more than a century-long measurements in the synoptic and climate stations with the so-called wind set. This is a German word. This circumstance required the application of alternative methods, in particular using the utilization of other sources of data, and methodologically the most correct approach is to try to reconstruct or simulate or mimic at least the three-dimensional structure of the airflow in the area of interest and its variation depending on the mechanical impact of the terrain and the influence of the temperature stratification of atmospheric layer with a numerical aerodynamic model as is shown in the feature on the right-hand side. And actually, the wind regime in Bulgaria has been, the analysis of it is subject of scientific interest in our institute more than a century. And taking into account the territory and especially the complex terrain of our country, as well as the fragmented coastline of the Black Sea, it can be stated that the stations with modern anemometer, the anemometer is the tool for measuring the wind speed and direction, are insufficient, and correspondingly the measurement network is relatively scarce. And next slide. Yes, there are many possible solutions, but we have selected the wind model Wind Ninja due to some very reasonable merits, I can say, of the model. This is initially this model is developed and maintained in the United States Forest Service section for fire science lab. And this the model is initially designed to be the wind driver for fire behavior simulators. But we have used them to reconstruct the wind field of a certain point of interest, and the reasons for our selection are listed below. The model is based on fundamental conservation laws, mass and momentum, and is tailored to operate in the sub-kilometer spatial scale, which means there is no empirical or semi-empirical dependencies. The model is tailored to operate over complex terrain, encountering also the influence of the temperature stratification. From practical point of view, it's very important that the model is free of charge and open source distribution. It's possible to install it in modest computers like PC. There is multi-platform versions for Windows, what is especially for me important version under Linux, and a possibility for exploration in batch mode. It's mean without graphical user interface, and relatively low demand on input data, flexibility, and easy usage. The next slide. This is the principal flow chart of the model. On the left-hand side, the input data. The wind data can be delivered in three forms: as domain average wind, as point initialization from measurement stations, as we'll show further, and from weather model in broader sense, in form of gridded data. It's mean from a numerical weather prediction model, from a climate model, or from reanalysis. The Wind Ninja uses also additional data, namely digital elevation model, of course, vegetation type classification, most simplest form, 3 classes only. This is needed to compute the surface drag. It means the friction of the wind with the surface, and cloud cover and temperature. This is necessary to calculate the temperature stratification, which alters also the airflow. The model has 2 computation cores. The first one is the default one, the conservation of mass. And the second one is more sophisticated. Conservation of mass and momentum is based entirely on the very famous OpenFOAM toolkit, which is installed in our computer Ravi2Hall. OpenFOAM is installed there. And the output is also very flexible. It can be grouped in 3 groups. The first one is GIS-oriented output for many GIS applications. The second one is a raster data in form of ASCII formats. And the third one is also in a standardized format, the so-called VTK output, the full 3D field. And the main merits of the model are listed here. Actually, this is the theoretical background. The model seeks to minimize the change from the initial wind field while conserving the mass. and it's maybe this is not so important for the presentation. The function to minimize the constructed using is use the square of the difference between the adjusted wind field and the initial one. The minimization is subject of constraint that the resulting wind field must conserve mass. Using the Lagrange multiplier theory, the problem becomes one of minimizing the modified functional, which can be reduced to elliptic particular differential equation. And finally, this equation is written in weak form and solved by means of the Galerkin method. Very elegant solution, actually. The next one was describes our numerical setup. In order to estimate the simulation capabilities of model, we have selected two domains with relatively flat terrain, one over North Bulgaria and one over Southern Bulgaria. They are chosen in such a way that in each of them there is a constellation, the smallest one indeed, keeping in mind the position of the stations in our network. In each of the test sites, there is constellation of 3 base stations, and in the interior of these yellow triangles, there is one station which is used as a reference station. And our idea is as follows: we try to simulate the wind field in the triangle interior with initialization from the wind in the points in the triangle, and we compare them with the wind in the red dots, with the references. This come next. This is the geographical coordinates of the stations, and here most important is the distance of the stations to the reference point. It can be mentioned that the distance is quite big. The model is actually tailored to deal with typical distances of couple of kilometers. We have here more than for Sweden, for example, more than 100 kilometers. And in the feature of the right-hand side is the construction of our standard anemometer for the wind direction and speed. Next one, this maybe I have to skip this one. This is the short explanations of what have we done. Actually, we have constructed a set of EO input-output programs, specially tailored, designed to deal with the output of the Wind Ninja and to feed the Wind Ninja with data. The simulation period is 1 week on hourly basis. It's mean for each of the both domains we have performed simulation for 168 hours. Thus far, we have used Wind Ninja with under Windows using the Wind Ninja graphical user interface, but on later stage we will skip this one. We will use the Wind Ninja in batch mode to integrate it in common computational framework for conversation between the geodetic coordinates and the universal transverse Mercator. We have used the very famous generic coordinate transformation tool, PROCH. It's maybe you know it, maybe. It's actually PROCH is the core of such very famous programs. Oh. 1 minute now. The results now we have compared for the both domains. We have compared the wind, the computed and the reference wind velocity, as well as the bias of the wind direction, shown with this formula. With black is the reference velocity, with red is the modeled velocity, and with the blue one, according the right y-axis, is the difference in the direction, despite the fact that the model generally reproduces the general course of the wind speed. It can reproduce it exactly. Maybe the next two figures are the most relevant one. This is actually one snapshot. The white stations, Vidin, Pleven, and Vraca, the base stations, every fifth vector of the simulated wind field is drawn here. The wind field seems very reasonable from a fluid dynamics point of view, very smooth, very consistent without any abrupt changes, but nevertheless, it's different from the reference station in Knija. Actually, the same situation in southern Bulgaria. The wind is prevailing southern direction, but nevertheless, the difference with the reference station in Haskovo is significant. And that are the wind roses. You know maybe what wind roses mean. This is a polar diagram of the wind for test one. Here can be the differences between the two roses are significant, but nevertheless the prevailing westerlies, namely the frequency of the wind from western direction, is reproduced well. The same from South Bulgaria. Here even the direction of the wind is not, the prevailing direction is wrong. And now the conclusions. Most generally, the results could be summarized as non-consisting and contradicting, and subsequently the major question about the applicability of the model to the intended task remains open. But nevertheless, we are still optimists. We have still no convincing arguments for the reasons for the revealed departure of the simulated values from the reference, but the most probably, and according to our conversations with the author of the models, the primary one is that the basic stations are too far from the reference one. And our next plan is to use data from a numerical weather prediction model or from reanalysis, which delivers a wind field with very, very high special resolution. And from operational point of view, it's necessary to build wind-in Linux, which will allow its efficient linkage with a common framework with our other programs. And acknowledgement to the one of the authors of the model, Dr. Nathalie Wagenbrenner, into the national program reduction of risks of adverse events of natural disasters, approved by resolution of the Council of Ministers. And before our final words, we are open for collaboration. Hence here some magic words: collaboration, cooperation, friendship, brothership are crucial. We are open to share our experience with other experts. Thank you for your attention.
So plenty of information, but unfortunately we ran out of time, so not to lose any time.
One question. One short question. My question is, when I saw this graphic with modeled data and measured data and distance, what you use to measure the distance?
Actually, the distance between the stations,
Between the results.
the results are there was comparison of the wind speed in the station, the closest point from a wind ninja to the reference station. And this was only which slide? Maybe.
The last. Blue line was the difference.
I show you. We prefer you. Full screen, please. The previous, please. The difference is the difference in the angle is calculated according to this equation. That's why it's stated. It's actually a difference in circular coordinates. And maybe this was computed. It's directly. I put this formula in the GNU plot script, and actually it's have to be mentioned that the error in the direction is much significant than the error in the wind speed, but this could be rooted also in the initial orientation of the anemometers in the reference station also. Actually, the reference stations are not so a reference maybe.
Okay, but try for you to geometrical difference. And maybe the results will be better.
Thus far, no. That's why the results are preliminary.
Okay.
Thank you.
Thank you for this interesting presentation. I'm curious, and this chemist, I would like to ask when you speak about mass preservation, you consider the atmosphere as a flow and as pure atmosphere, or you consider a different kind of particles inside?
No.
Where can so these are reactive part of the model.
Interesting questions. Number of Knudsen. There is actually we speak about continuous fluid dynamics.
Yes.
Namely, the fluid is continuous. There is no intermittent stages, which is measured in the fluid dynamics with the so-called Knudsen number, which is important for, as I know from this project of Professor Maginu, for very, very small devices, filters and so on, where the airflow cannot be regarded as a continuous fluid. But this is in submicron distances, and we here deal with kilometers.
Maybe you can consider such a chemical model like super empirical one.
What?
An empirical model that represents the chemistry in.
No, there is no chemistry at all.
Okay. Yes, okay. Sorry. Thank you.
Okay, so let's continue. Actually, the microphone was yours. So just short to present you is Associate Professor Liliana Naidenova. Would you say some?
Yes, she finished chemical department of Sofia University. Now she is an associate professor in Technical University of Sofia.
Thank you, dear colleagues. Good afternoon to all of our listeners that still have some patience, always also in the internet. I would like to express my gratitude to the organizing committee for providing me the floor to present and postpone the regulation, which was initially planned for the first day. However, I will now talk not about modeling. I will show you some purely experimental work, which is focused on experimental measurements of fine particulate matter which is extracted directly from the hot exhaust gases born in the combustion process or any kind of thermochemical combustion process. The focus is on biomass combustion. We are doing a wide range of experiments in the field. And in this particular case, I will show you the case study, which is focused on combustion of agricultural biomass, which is something considered very actual and it is very important. Yeah, the content is typical, so I'll skip this slide. Just a few words for introducing our motivation. The problem with PM exceedance in the atmospheric air is obvious and is well known for already decades. And we clearly know that combustion processes from household combustion up to different industrial applications are major, also transport vehicles are the major reason for observing the exceedance of different type of, especially PM10 and PM2.5 in the tropospheric environment, in the ambient air. So we have focused, we are one of the few groups that are not focused on the practical application of the PM content chemical composition for those kind of particulate matter that is collected from the atmospheric, ambient atmospheric air. But we are focused on the particulate matter which is formed in a typical conversion process. So we believe we work with relatively young particles and we are able to obtain some more information about their particular properties. How do we do this? We use so we use different kind of experimental setups capable of first providing the opportunity to do the experiment in terms of chemical or thermochemical conversion of some particular matter. In this particular case, we work with, as I said, biomass from agricultural origin. And the major issue is to experimentally measure the primary gaseous pollutants as well as particulate matter and the related kinetics governing the combustion process itself. After we do so, we can further put an effort and evaluate also the properties of the particles itself. So this particular experiment is carried out in conditions typical for fluid and reactor because it is believed and it has been already proved 10 years, more than 10 years ago, that this is one of the most perspective from efficiency point of view method for burning a low quality, any kind of low quality fuel, including biomass or solid biomass fuels. Why it is low quality? Because I'll say this a little later. So in this particular case, we work with peach stones and ash stones that can be directly burned if you have sufficient burner for this reason. So in this particular experiment, we use this type of biomass for we burning it into this, as I said, the laboratory scale reactor, which is electrically heated, and this provides a particular constant level of temperature, of course, and pressure within the fluidized bed. The operational conditions are set in such a way that we assure having preset steady state conditions and fixed airflow rate, pressure and temperatures are well controlled during the entire process, as well as the concentration of oxygen in the reactant flow and in the transport state. So each series of experiments must be repeated between 4 and 10 times in order to have statistical interpretation of the results. And the effect of different operational parameters can be easily studied having such an experimental setup. You can see the drawing of the experimental setup. So on the left-hand side, you see the reactor itself. The red zone is the fluid aspect of the reactor, where you have this unique and constant temperature conditions. So the fuel is dropped into this vent from the upper part of the reactor. And on the left-hand side, you can see a simultaneous measurement of the primary gaseous products as well as the particulate matter. Depending on the type of instrument you are using to measure the particular matter, you usually have two different technologies used. One of them is based on the spectrometric instrumentation, where you can basically provide information mostly on the particle size distribution, as well as the particle number density. But if you have a gravimetric measuring tool, then you have the opportunity to collect PMs on different stages. PMs with different groups of different diameters, and later go for different kinds of studies, including chemical characterization of the different series of particles, as well as some clinical tests using different types of cells. So we have such a similar study in another project, but I will not have, due to the limited time, I will not go into details. If someone of you is interested, we might go later. First of all, we need to know what kind of fuel, what kind of biofuel we are using. So the stones, the beaches and electrical stones must be initially characterized as well from chemical and physical point of view. This includes approximate and ultimate analysis, colorimetric analysis, thermal analysis, lignocellulosic ash analysis, and additional if needed. So you can see some of the information provided from the different analytical methods used. These are characteristics of the biofuel itself. So you can see a particular interest to our team was the fact that we have confirmed that any kind of biomass material is rich of volatile organic matter, and it could be also rich of moisture. In rare cases of ashes, but the level of fixed carbon, according to the approximate analysis, is usually very low. However, the high heating value of biomass is quite a good number. In many cases, above, for instance, the heating value of lignite coal or even brown coal. So therefore, from this perspective, one can consider using solid biofuels as fuels, but not only, of course. So these are the few graphs representing some of the results which we have obtained from the thermal gravimetric analysis and the different curves presenting the energy related effects out of this observation. You can clearly see three major stages. The first one from the left to the right. The first peaks speak about or show the decrease of the mass due to the evaporation of the moisture content. The second peaks are dedicated to evaporation of the volatile matter, and the last stages of these graphs are related to char combustion. As long as we have very limited char composition in the initial mass of the fuel, we can obviously see almost no energy effects, energy-related effects. So out of this experimental data, one can use different type of simple methods to introduce or to estimate some kinetic parameters which are important in case one would like to describe the chemical kinetics besides the entire process. So this is usually combustion is not process which we usually express like C plus O leads to CO or CO2 depending on the concentration of O in the flow mixture or the reactant flow. This is not the case. Normally a combustion system can consist of at one at the same time simultaneously one can observe several hundreds of species that interact and actively participate in several thousands of chemical reactions. So these are really reacting systems. A combustion system, the flame and the different zones of the flame are very interesting from physical chemical point of view. Reactive systems that provide a lot of information, and to build such a complex chemical kinetic model, one needs to obtain all these Arrhenius type kinetic parameters. So this is one way to obtain it. If you the experiment from point of view, if you can conduct an experiment and one can measure the concentration of the major projects also, as well as some intermediate projects, and in this way to investigate in deep the different pathways leading to the final process in a combustion system. So we have decided here to show you the way we have calculated the instantaneous rate of carbon conversion and the cumulative one. Why carbon is the major element from the ultimate analysis you have seen before. And this is the way it looks. So we have this kind of picture, especially the one on the right-hand side, the curves from the right-hand side show you that we have almost complete combustion at the end of the reaction time, which proves that the experiment has been conducted according to the rules of procedure. This is the another interpretation of the rate of nitrogen conversion, which was compared to the absolute nitrogen first annual emissions and the relative nitrogen content. So one can conclude by looking into this overcrowded graph, one can conclude that the flue gases samples show higher nitrogen content for those samples that are having higher nitrogen content, like for instance here with the 80% case. And the flue gases contain higher absolute annual emissions, but at the same time lower N conversion rate or nitrogen conversion rate. This is because the nitrogen is normally fuel bound and it takes a little time to oxidize it in temperatures below 1000 Kelvin or around 1000 Kelvin. So if we increase the combustion temperature, we will have it completely converted to NO. Another, and I think very interesting observation, we have confirmed this kind of result for more than 15 solid biomass fuels which are available at the Bulgarian biomass market, energy market. What we have observed in many cases is that the peaks of the PM particle concentration appear in the range of particles having mean diameter or aerodynamic diameter lower than 1 micron, which was a very interesting observation. In some cases, we have B models size distribution. For these particular types of biomass fuels, solid biomass fuels, we have unimodal distribution. Speculation about this are also available regarding the approximate concentration of the major structure containing components of the biomass fuel. So, in order to conclude, I would like to say a few words that in most of the experiments performed, we have different reactors. So the fluidized, the reactor, the workhorse reactor that simulates the fluidized bed combustion is just one type. We have also a fixed bed reactor, tubular flow reactor, and so we can perform the combustion conditions, different combustion conditions, which are organized in a way to provide the opportunity for good control over the operational conditions. In this way, we pretend we have experimental setup providing the opportunity to collect different types of particles and providing a lot of details about their chemical compositions, size distribution, as well as particle number density. In general, in this particular experiment, the bed temperature and the initial mass of the fuel particle was found to significantly influence the conversion rate in the experimentally measured gases and particulate products. As I said, most of the nitrogen that was converted to NO was basically the fuel-bound nitrogen, because we believe it is so, because we have collected the NO, so we have measured the NO right after using hot sampling line connection between the reactor and the measuring device, as well as we have a very, very short length of this measuring line, and we do not provide conditions to give the opportunity to the nitrogen appearing in the mixture due to the airflow rate to increase significantly or to influence significantly the NO concentration into the flue gases. As I said, we have, in most cases, we have observed semi-normal PM size distribution, as well as we have confirmed for all the studied biomass fuels that the ultrafine fractions, so I mean, when I speak about ultrafine particulates, I speak about particulates having aerodynamic diameter lower than 1, equal to or lower than 1 micron. So this fraction is usually providing the largest particle number density. This is a fact that it should not be left without attention. And at the end, the PM absolute and the relative flue gas concentrations were generally higher in those type of biomasses having higher content of volatile organic compounds. There is a direct relation between the proximate content of volatiles into the biofuel used and the PM concentration in the flue gases. This was confirmed in several studies and is already well approved and published. And because we all are very tired at the end of the day, I would like to thank you for your attention, providing me this opportunity, being with you, and sharing my personal experience. I'm not doing all this alone. I have a few collaborators, Technical University of Sofia, willing to enlarge the group of collaborators. So if you have questions, I will be more than happy to answer.
Any question? Last chance for questions.
Maybe only the one short one, maybe a little bit stupid question. Is there any organic compound after the combustion in these biofuels at all?
Yes, this is not at all a stupid question. There are a lot of organic compounds in the flue gases, but we do not measure them every time because it needs more expensive equipment, which we do not have. So we are doing it in collaboration with other universities, like Technical University of Vienna, or we used to work also with Lisbon University. So if you have gas chromatography or mass spectrometry attached to your flue gas system, then you can obviously see the concentration of different types of organic compounds, including pHs. Another study we have done, we have provided in one of the projects I have shown, we have provided collected samples of PMs, and unfortunately it's not in this presentation. In our gravimetric analysis, we have a very interesting measurement device for PM particles. We basically separate using this impact, we separate the particles into 14 different stages. And on each stage, you can find particles which diameter ranges in a limited range of diameter. So for your information, the highest one is 10 microns, the lowest one is 15 nanometers. So we go to very low scale. And all this, so what we have confirmed from the chemical analysis, that as lower you go, the smaller particle, the concentration of organic compounds, as well as of carbon itself, is above 90%. So this is basically soot, Mars, black carbon. Black carbon is not on. It's not. I would speculate a little bit that soot and black carbon is something different. Anyway, so we have quite a lot of. We put quite a lot of effort last 10 years, and we really have a lot of results. So if we can help the atmospheric models in a way, it would be very interesting.
Thank you.
Let's thank to all. Excuse me, we have a question.
Another layman question. Actually, you from the past, you burned out those, let's say, samples from the apricot and from.
And this is in this particular case, it was apricot and peach stones.
In this particular case, but as far as I remember, during COVID, there were some masks produced with apricot and peach stones.
This is different. You can carbonize this kind of material and produce something like a material which is similar to the activated carbon.
Yeah.
But this is another procedure.
It's another
It's a complete. So combustion is when you have a combustion, when you have oxygen in the reactive phase. Yeah. But if you pyrolyze. If you do something like pure thermal decomposition in an environment lacking of oxygen or with very small little amount of oxygen inside, then you can produce a carbonized material which is similar to the activated carbon, which can find thousands of applications in companies. We do also this interesting investigations. For instance, a colleague from another institute have provided us some samples of lignin, which was a kind of residue material from ethanol production. And they say we have a pile, like a mountain of lignin, and we don't know what to do with it. So we have carbonized it and provided at least 3 different options for further application.
Okay.
This is a good way to, you have to circulate economy.
Thank you. So, as we said, that's all, folks. It's time to give the floor to the director of the center.
Yeah. To all present.
Thank you very much. I see that it's very interesting. Very interesting discussion, and actually, that is the idea of the call.
Yes.
To have more discussions and to become more interesting. And I see if we have another day, maybe it will be more interesting and more interesting. Every panel is very interesting. I would like to give to Professor Iliana Nailova also the certificate of appreciation for contributing. And also to Professor Christo Chervenko. Soon you'll become, I'm sure. Thank you very much. Already you have it, it's enough for one panel. And also, you can sit down if you want. Thank you very much for your contribution. And I think that it's time for our closing remarks for the conference. And I would like also to invite our moderators. This is after that. Our moderators and to thank to their contribution to the conference to Mr. Steve Brecker. Thank you very much, Steve, again, and I hope to see you again next year on our conference. And also, yes, thank you very much. Thank you again. Also to Nina Dubrinkova.
We have organized it, but also very valuable partnership with for the conference. And Professor Stefan Danova is very much for captain of this conference. Yes, thank you. Now it's time to say some words about the conference and what happened these 3 days. I'm pleased to make a short wrap up of the second and third day actually, because we already made it for the first day, and to make closing remark of the conference. Yesterday we deeply went through the topics natural and human in dust hazards, high performance computing, modeling and simulation, graphic information system for environmental monitoring and artificial intelligence, waste management and water resources. Today we had lectures and discussions on the high performance computing, disaster medicine, risk management and assessment, climate change challenges, security implications. All topics cover different subtopics that have broadened our knowledge and expertise in the CMDR domain. It is needed my pleasure to express gratitude to all of you who made this event really, because all the topics that we have gone through are critical to the operations and performance improvement within crisis management and disaster response domain. We covered a broad spectrum of topics from cutting-edge technologies and innovative policies to community-based approaches and international cooperation. All this analysis and researches of the implications connected with the environmental changes and the cause emergencies shown in the presentations during last days. The discussions made us think together, and being proactive, we realized that a more adaptive and comprehensive approach towards the new environmental challenges is needed. Using our expertise and future collaboration together with the high performance computing and technology, we can be able to at least predict and the damages of eventual disasters, to mitigate the risks and to make us more resilient in order to minimize the negative consequences from such events. Through our collective efforts and shared knowledge, we can develop more effective, inclusive and sustainable solutions. The CMDR COE promotes cooperation in crisis and disaster response throughout its activities, and thus contributes significantly, not only for local, for national, but also on NATO level and European Union, and our partners to achieve their objectives in relation to this domain. I sincerely would like to thank to all of you for who've been these 3 days here in the hall, and also to our guests online session and YouTube and WebEx session which presented. I saw that we have more than 500 participants in different days, and this is a very good achievement for our conference. Another thing is that all these articles will be issued in Springer proceeding, and I hope that to the end of the year we will have in paper everything what you presented today. Of course, you are invited, and also, as I mentioned, this forum is not only for presentations, but also for discussion and to talk each other for new projects. Even only for these 3 days, we already have 5 new proposals for new activities and how to collaborate in the future. Especially I would like to mention that almost it's official that next year the Ministry of Interior, together with us and Euro-Atlantic Disaster Response Coordination Center, will host a huge NATO exercise, including a lot of partners and NATO countries here, and we will try to connect tactical level who are responders with operational and strategic level planners of different
topics, wildfires, floodings, telemedicine, and etc., etc. It will be also connected with some workshops and conferences, and you are more than welcome. I really hope with our colleagues with Climate Change and Security Center of Excellence, actually the newest Center of Excellence, 31st, I think, 32nd Center of Excellence in NATO network, and we will trying to deep our cooperation and to working together, because the climate change is so related with disasters and consequent management, and also the crisis which are caused by disasters, and especially for security on national, regional, and alliance level. Also with Bulgarian Academy of Science, we will continue to work and really hope to deepen our relationship and to use this call for a lot of other events. Thank you one more time, and I would like to also to conclude with some applauses to our staff, our CIS, Christina, and the conference director, Colonel Disislav Zmes. Without each help, we cannot. Especially, I would like personally to thank you from my name, and Nina and Petya and Stefka, which we are some kind of organizer of this conference, to Christina Christova. Please, Chrissy, come to see all people to see you. To succeed to manage this year this huge flow of connection with the authors and articles, and actually the achievement is a huge achievement to her to succeed this conference. Thank you very much to all of you. And of course, as I mentioned, thank you to all of you. And I would, with these words, I would like to wish you to stay safe and healthy, and have future cooperation and collaboration. Thank you one more time, and safety back home. Thank you. Do you want to say something? Some words? Oh, okay. I said that all from our side. Thank you very much, and see you next year.